my friend Mr. Hemant Pathak, who will chair today's technical session. A brief biodata of Mr. Hemant Pathak. Mr. Hemant Pathak was ex-vice president of our association MFAI, presently giving freelance consultancy in metal finishing technologies and is based in Mumbai. Graduate from Mumbai University BSc Chemistry 1981 batch and Diploma in Electrical Engineering from Maharashtra Technical Board in 1986. He has over 40 years of experience in surface finishing activities. He has worked in engineering applications of electroplating with companies manufacturing diamond tools, that is, Bukhanwala Diamond Tools. He has developed their zero point 0.5 mm ID and 1.5 mm OD hollow diamond drills for glass and ceramic industries. He worked with United Vendor Host Limited, a company engaged with repairs of marine and oil field components, and he was trained in Singapore factory for patented processes of porous chrome. He developed their pre-treatment process sequence for hard chrome plating on chilled cast iron substrate. He was associated in past with supply houses manufacturing electroplating chemicals and plants from Growell and GTZ company. He has worked in different departments like technical service, marketing, projects and exports during his tenure with the supply houses. He has commissioned many automatic plating plants for GMF successfully and given technical services to them. He was awarded by supply houses for his dedicated work. Now I welcome Mr. Hemant Phatak.
Hello, Ashish bhai, thank you very much for my introduction. We start today's session with our first lecture on zinc flake coating. I invite Mr. Kishore and he'll be presenting zinc flake coating. Mr. Kishore, welcome.
Hello. Hello. Yes. Audible, na? Yes, am I audible? Yes. Sir, thank you. Thank you very much for your introduction. Uh, Good morning to all. Actually, we here to explain the and represent the IFCO finishes and technology, which we have a technology of zinc flake coating. And the petty the we mainly into the zinc flake coating, and we provide deep spin coating machines also. So we will look shortly, one by one step, what we are going to show in that presentation. So we will cover into this seminar uh, what will be the corrosion economic impact, what will be the issue, why we develop this technology. We are going to cover into this how we overcome into the fastener industries by this technology. After that, we how is our technology and engineering works, like zinc laminar science, or how we work for C5 or CX environment, and core product architecture. We also validated by the performance of the zinc flake coating, comparative analysis with hot dip galvanizing and electroplating. After that, we will look after the zero liquid discharge, carbon footprint analysis, and CBAM readiness and ESG value. After that, we can check applications and sectors where we are providing these technologies. Generally, we IFCO finishes, we have a R&D center in Pune where we formulate this zinc flake coating. After that, dip spin plant where we do the actual coating works in Nasik location, toward the center side. And strategic alliances, global partnership, that we have a manufacturing hubs in Europe, and India is our headquarter, and after that in Asia also. So after the technology, we can check this is in if we consider the for the durability for long term performance, we can withstand in C5 or CCX corrosion category up above the 100 plus, sorry, 1000 plus of salt spray hours. And also got cold dip galvanizing is also, we have the process. So we can save the energy by 90% that we do. If we check in a hot dip galvanizing, there is a temperature go up to the 450 degrees Celsius. In a hot dip, if we say we can cure the paint up to the 200 or 250 degrees Celsius. Also, top coat we provide with the coefficient of frictions 0.12 to 0.18. Actually, the what is the problem and why we develop this technology? As all are the aware, the corrosion will start in the at the connections point, at the joints, small surface area, and in offshores or onshores, marine sides. Mainly the corrosion will happen, and that we need to protect by we as we zinc flake coating. We provide that performance to protect the from this. We protect the surface or from the corrosion. Actually, if we see in C5 CX environment, air or the humidity is more, wettability is also more. So chloride content, pollutants, hazardous substances are very towards that, towards the at that area. So basically, that is the reason we develop we develop this technology to protect from the corrosion. That is our basic agenda. So strategic insight, if we check C5, CX conditions, corrosion efficiency, not zinc mass, we define the service lives of that product. Basically, in fastener industries, we are providing this product. After we check regulatory, the norms in industry going day by day and increasing, because we cannot hazardous waste into the earth, or we can say we have the restrictions of use of water. So we have to uh, develop another options which we can reduce the use of water against the what we say the technology. As we develop a zinc flake coating, we require the water for only the degreasing stage. After that, we do short blast. For degreasing, the degreasing process, only the oil content is there. That hazardous waste is very nominal. So the restriction, we as we say, any hazardous substance, PFAS is there. After that, no any chrome, no any hazardous PB or lead. Lead is there, or we can say chrome is there, or cyanide. We cannot use into this technology. So what restriction we have from the CP, CB or SPCB? So that we actually we follow the government rules to use of these hazardous substances. If we say, sir, global phase out supply chain elimination of legacy additives, compliance tightening. So ROHS, CPCB enforcement is there. So we have to restrict this use of hazardous wastage. After that, technology failure is there. Due to the process failure, zinc intensive system, full new ESG threshold is there. ZLD incompatibility, water and influent mandates block platings. After that, market adaptations, total life cycle cost replaces initial prices as the key metric. Carbon intensity, if we see, become primary commercial of our currency. We actually not promote we save the energy by reducing the what we can say the curing temperature as against the plating and hot dip galvanizing. So our curing temperature is also very lesser side, 150 degrees Celsius to 200 degrees Celsius. And thin film as compared to hot dip. I will show you the comparison hot dip galvanizing and our technology. Actually, what is our vision, philosophy, and approach? We define actually what is the corrosion category first. Before going to proceed with any client, we will check the what is the corrosion category we you looking for. After that, we check the geometry of that part. How the part, it is the threads or fastener or what, we need to check that. And after that, functional need, what is the torque tension you require, and any fatigue is there. That basic things we check. After that, we recommend the technology which is suitable for your products. After that, the carbon and ECG compliances is there. So C5 first engineering we do for C5 or CX corrosion category products. After that, thin film as compared to hot dip galvanizing, and hydrogen roughness or toughness we can say embrittlement, safe. This is the complete chemistry. We can say we never use the acid during the process into uh, when we are going to this process parts. So no acid pickling and nothing. After that, ZLD and CBAM we have aligned, not required ZLD or CBAM, as you know, the we have already aligned product. Core products of corundum or our IFCO finishes, mainly the Ecomet corundum, that is zinc laminar system. We provide Ecomet titanium CDG also and corundum 1. These products we give in a thin film up to the 15 micron, 8 to 15 micron, with the performance of after torque, sorry, without torque, we can say up to 6,000 hours, up to 6,000 to 6,500 hours. And in Ecomet CDG, if we see non-electrolyte and cured at 200 to 250 degrees Celsius. And in corundum 1, this is our actually the base coat product. We give the better adhesion, friction control to the products. Common platform that we contribute PFAS-free product, hydrogen embrittlement safe, chrome-free, and thin film efficiency. Yes. We have a top coat also that we provide. We have these top coats generally are not a, as you say, top coat not to provide a color. It will provide the frictions and protection by the what we can say controlling the sealing and durability also. Actually, if you see base coat is underside and top coat is above the base coat. But if top coat is the first layer which retard the hazardous substances from the environment. That is the key player in the that painting or we can say in a coating. If we see functional layer architecture, the it will work as a activation the process, low temperature curing logic for the process efficiency. After that, it will work as a sealant. It will just like block the small blocks or the pores. After that, it will resist the UV also or UV exposure and heavy pollutants in the environments. And it will work as a frictions also. Friction control it will gives. And of course, the handling is PFAS free product. That is the main our we can say the strength or technology. We have also we can provide the deep spin machines also. For the small parts, we cannot do by spray method or by hanging method. For the fasteners and small components, we can do by the deep spin technology that we machine also we provide. And that machines are automatic, semi-automatic, or can say PLC with SCADA, that products we provide. And with safety interlocks is also there. The generally this core technology, how it will work. First dip, after that the spin is fully alignment with CP, CV and SPCB norms. Export ready documentation that project we provide. Also integrated safety locks as the complete system is the fully automatic. That's we have to check for the safety locks also, interlocks also. The key sector or application we can say where we work for is the automotive or what we can say uh, railway or constructions or renewable energies, that into that field we provide this product or these machineries. Yes. How this technology works? As you know, the our air contains pollutants like chloride, sodium, or oxygen. Oxygen is in the air, heavy humidity with water. So basically, our coating is work as a sacrificial layer to protect from these pollutants and absorb the inhibitor water, air they absorb and work as a sacrificial material, or we can say the layer. It will work as a sealant, or it will we can say the self-healing behavior. It cannot damage by attacking the pollutants. That is our that technology or that product, we can say it will work as an inhibitor, or we can say the self-healing. A C5CX environment or corrosion category products, how differentiate the engineering? We can say the high chloride. If we see into this environment, there is a high chlorine content or high wettability. Due to that, the corrosion will happen fastly. So this product, how work? This product provide the good corrosion resistance as compared to electroplating and hot dip galvanizing. Generally, the dip spin and spray application we can do by this paint. How we can say the process control in dip spin is there, and if we see for the we dip spin provide for the smaller part, and for spray we can say for the larger part. After that, we say we can do the painting by HVLP or electrostatic gun also, and thickness is we can maintain up to 8 to 15 micron. Generally, the we can say the difference between hot dip galvanizing and the our product. Generally, if you see, mainly we focus on this temperature for 450 degrees Celsius is there, and coating thickness. If you see the higher coating thickness, 45 to 100 micron is there. So our technology only if you see 8 to 12 micron, and here 45 to 100 micron. The consumption of paint is also more, and the performance, if we see corrosion resistance, I will show you in next slide also. Basically, this is the difference between hot dip galvanizing and our product. Yes, in zinc flake coating, generally the 200 degrees Celsius or 250 max we can go. Yes. Okay. And comparison with electroplating, if you see there is a hydrogen risk, and C5 durability is there, and ZLD required. In IFCO system, there is, if you see, hydrogen embrittlement risk is totally eliminated. No use of pickling or no use of acid is there. So generally, this is the difference between zinc flake and our technology. Yes, this is our performance actually for our zinc flake coating. Yes, this is the one actually salt spray. We after the uh, we can say before tapping, or we can say yes, before tapping we can give up to the 6,000 or 6,500 salt spray also. CCT is also there. CCT we can we have did the test 8 cycle we pass. 8 cycle. Yes, friction reliability and torque tension. Due to the torque, we damage the paint or excess torque is there. So due to the if we can say in thread assemblies, 90% of torque is consumed by the friction. That yes, that is actually the environmental or impact is how the we work for the greenery of the our environment that we focus mainly we focus. Yes, ZLD impact analysis we have done how our technology is greener as compared to plating and hot dip galvanizing. This is generally the resources or what wastage we have from the our product we shown in the yes. Yes, we work for carbon footprint also. And yes, CBAM readiness, we are ready. CBAM readiness product. Yes, carbon credit and logic and ESG value is there. So we we reduce the carbon reduce emission by doing the low baking or low temperature product by using. Yes, general application where we are doing actually renewable energies, automotive and infrastructure, railways, heavy industries. These are our main industries. Yes. Thank you, sir.
Thank you, Mr. Kishore, for giving a in-depth information on zinc flake coating. Please wait. Uh, a small memento from MFAI. We start with our second lecture. Uh, the topic is anodizing, and the presenter is Mr. Subrato Chakravarti. Uh, he is head of the department in Gror and Well R&D, and he's been working for last 33 years in the field of metal finishing activities. I welcome Subrato Chakravarti. Subrato has 33 years of experience and a very well-known figure in India as well as on international scenario of metal finishing. Please take over, Mr. Subrato. Thank you.
Thank you, Mr. Pathak, for extending, a description about me. Good morning, ladies and gentlemen. We are at the third day of the show, and thank you once again to MFAI for organizing such a wonderful exhibition platform wherein we showcasing our products. And thank you all to be with us today morning. And today morning, what is my topic is uh, anodizing emerges as a very interesting coating for the finishing of light metals, and especially aluminum. I am going to talk today. Well, these are all known to all of us, but just to start with the background that it forms a integral part of anodic oxide layer. 1/3 remains inside and 2/3 goes up. So dimensionally, it goes a little bit up. And there are three categories. Category 1, 2, 3. Basically, one is for the aerospace industry, where inner coating. 2 is the main workforce for the aluminum, processing or anodizing industries, and which I actually talk more on that for the decorative as well as corrosion resistant platform. And of course, there are hard anodizing, that is the category 3. Again, I am not going to talk much on that because supply house do not get any chances to sell any products in category 3. Okay, moving forward, there is the several application. I will not go through in details, starting from the medicinal device to EV platform, the anodizing is used. And sooner or later, I see this all emblem of car industries, which we see Hyundai, Suzuki, and so on and so forth. And maybe we will not see the nickel chrome plated parts. We will see only the anodizing. Well, little bit basic about the formation of the coating. We are all aware of it that there's when the oxidation takes place, because this is a we call this a reverse reaction. Normally in electroplating we deposit metal. Here we actually leach a little bit of layer, and we can see that there is a barrier layer here, and on the barrier layer this porous columnar structure is being formed. And since we get a lot of pores over here due to the second reactions, we get chances for depositing a lot of dyes and getting to different colors. Okay, we see this is the realistic picture, and we see surface morphology of an anodic coating. You can see there's a lot of uh, black dots, which are basically the pores what we have seen just before that on the schematics. Okay, as we know that the anodizing is not only on the decorative platform, but it is being used nowadays in the other durable coating industry. So there are a lot of variables which actually affects the anodizing coating and its characteristic. So it is very important whenever we do anodizing, we need to know what is the basic materials and all the other parameters, and we have to look into. Some of the parameters are mentioned over here, and that influences the coating characteristics, and which is very important that we have to control whenever we do or certain conformance of any specifications. So these are different properties. I will not go into details, but one thing I can tell you that it can. Hello. Normally in metal finishing, I think we get a lot of problems sometimes. So it is one of them. So please excuse me. But anyway, the what we discussed so far, that there are several good properties which anodizing can offer. I'm sorry. Okay, so it can give high corrosion resistance, decorative application on all different colors, and of course, it can give very high corrosion resistance. And as far as the data is concerned, that it can give corrosion resistance. I mean, the service life of 25 years at different application. So, but while doing all these things, as I said, that there are different parameters like the base metal composition, there is a solution characteristics, a concentration of acid, concentration of additives, and concentration and different processing sequence. This plays a very important role. I actually thought of showing some processing step of some of the difficult alloys, which is going to come when we move from architecture to automobile or other spaces. So those things are actually planned. I don't know whether we can solve this metal finishing problem or IT problem, right? Okay. Yes. So we solve the problem. Thank you, Mr. Kindra, and thanks our chairman, Mr. Padak, to accommodate that. Okay. So development strategies I brought in while that actually what we have done it is we talked about the etching parameter, dismatting, SAA, that is the class 2 sulfuric acid based system, and of course sealing. And what we actually did is that composition analysis and checking about its impact of the usage like NaOH or KOH or other additives, acidic type phosphosulfuric base, and with some additives, and its impact on the particular substance and this coating. Then we also working on for the development of different dismutting chemicals, because moving from the traditional nitric acid to nitric plus additive, or in some cases sulfuric acid, to make the system totally nitric free. Okay, in Anodizing, we have seen a lot of pores and other parameters which you have already narrated. And here also we have tested some of the additives to influence the pore structure so that we can get a better adhesion for the dye or other top coats. And most important, the dyes are all, we've seen the pores, we have put dye. So the dye has to be, this pore has to be sealed. Otherwise, it doesn't give a corrosion resistance or the color fastness. So that's very important to work on sealer. And of course, as I told you earlier, that we have validated all this working on different substances, 2000 series, 6000 series, 5000 series, and 7000 series. So moving with the first one was the etching additive. Just traditional process is utilizing NaOH. If you do with NaOH, you will get a lot of sludge and stone-like substances. With additive, you can eliminate that, and you can see the surface morphology of the. This is with the NaOH, but if we do with the additives, you can see this is much better morphology and not much crater inside on the surface. We have done it on 7075 series. Now you can see over here with the NaOH, we have almost, there are a lot of distortion on the surface. Whereas if you do with the additives, you can see there are little bit, but much reduced volume. Well, this is a unique processes. This is a free from NaOH or KOH. It's an acidic base process with some surfactants, phosphoric, sulfuric acid composites, with some additives and inhibitors and so on and so forth. The most important thing is, as we know that if you do NaOH etching on aluminum, you get differential etch on the surface. So aluminum is easily formed the sodium aluminate, but the alloying element doesn't go inside in the etching solution. So surface doesn't get very smooth. But if you use such type of additives, we can make it much smoother, and also the sludge contents will be lower, and it's much more greener chemistry, and bath life is also very high. So you can see this is the product, and then we have we can see that this is a before and this is after. We get a much whiter color. We have seen the effect of NOH. Now you see the effect of the acid-base system. Now here you can see that there is on the surface is more flatter, not much of etching as we have seen with the other cases. Moving towards the desmutting process, as we know that when the desmutting takes place, and I already told that the metallic doesn't go out and then it forms smudge, and the desmutting it goes after desmutting. Now there are some processes available nowadays. With the top one is with the nitric based system, and this one is nitric free process. And eventually what we get it is before and after. You can see much whiter and more better for the next processes. Here, this is very important is that you can see that these are some white powders which remains on the surface, but with the additives we will be able to remove that. That is good for a next processing. Let's move on to anodizing bath. Now, here is of course there's a basic composition is 200 gram per liter sulfuric acid and some additives. Now you can see the effect of additives. If we add, this is the organic carboxylic acid based system which reduces the aluminum dissolution. So eventually what happens to the user is that with additive we can you can see this 7500 liter bath is working with a customer, and after we started the bath with 11.2 grams per liter, then we added some additive, and after 1500 square meter of working, you can see there's a 0.7 grams per liter increase in the aluminum on the solution. So eventually what happens, if we add such additive, you will be able to increase the bath life, and the load to the ETP will be lower. And nevertheless, there are some more advantage associated with. Here you see this, we have seen this schematics, and earlier also we have seen this pore. Now with the additive, what it does it on the top surface, it widens. So what you see this, now if it widens, you can see the diameter of the pore on the top surface is little bit more. So as a result of which we get better dye adhesion, a little bit darker shade of a substance. You can see the part. This is without product additive and with additive. So it is getting darker. Well, there is another very unique product after anodizing when you move towards dye. And I'm sure if some anodizer over here sometime gets such white spots. Why these white spots are coming? We have seen this pore because it is not sealed yet, it is not dyed yet, but there are some inclusion of sulfuric acid in the system, and as a result of which the sulfuric acid, if doesn't come out, then subsequent process when it goes for the dyeing, it doesn't adhere to, so leading to the white spots. So addition of this what do you call a P additive or this rinsates, which are PFAS free processes, and also organic acid based system. So therefore the HASCAM classification is lower. It can be a good to go product for the user. Now moving towards some of the difficult alloys, which we industry knows that something to be done. So we have done some activity over here. Now you can see the parts, and this is the red dye based system. And we know 7075, the interesting issue is that high zinc, and that can create and normally create some problem while doing the traditional processes, and if you do the anodizing. So what we introduce over here is in dismutting we use this MFAI additive, and through this we will be able to influence the substrate better and to get smoother anodic coating. This is another difficult alloys, particularly interesting for the aerospace application. This is 2024, and wherein the copper is higher, approximately 3.8 to 4.9% for increasing the strength of the the base material. So what we have done over here is, again, you see that in this case we have added this NF additive, and that on the surface, if there is any copper is there, it gets eliminated and we get a better results. And you can see this is the part, bare parts and with dyed parts. ADC 6 LM5. Here also you can see the silicon is also little high. Of course, not as high as ADC 12, but is also higher than the 6000 series. Magnesium is higher, so that's also very important to take care of. Here, what we have done it is we introduce electropolising, and with the, of course, it's a sulfuric acid, phosphoric acid composites with some additives so that you can influence the surface structure. So we added 49 EP over there, and then you can see the parts. This is the basic parts, and this is a basically motorcycle, gear change, hand gear change apparatus. This is the we got a master sample, and this is the part what we have processed in our lab. Okay, this is ADC 380 and LM24. I mean, it's the same thing. Here you can see that again we have used this NF additive, and what we have done it over here is in dismutting we introduced this IPhenal on additive, and after that you can see the rest of the process is by and large same, and we get a black coloration. Of course, the requirement was black, so we get it done. Some of the qualification tests, very important, and this is my last segment of a discussion. Now you can see this is the dye spot test after sealing, because if the sealing is not proper, and if we put a dye, and we will lead to a situation like dye spot will be appearing. So what we did, the sealer, you can see there are two sealing agents we have shown over here. One is the cold sealing, and one is the mid temperature sealing. No, today for the solar platform, these mid temperature sealings are performing much better than when people want to get OPEX becomes cheaper, so that people use this. Yeah. Sorry. Well, this is a mass loss test, very important, because if you have to conform any automotive directives or any OEM directives, so this is very important, because if you put an anodized coating and if there's a mass loss takes place under the influence of some of the other ingredients, so will be losing the base material, so it's not good. So here you can see that this is a comparison with the hot sealer contemporary processes available in the industry, and we have done it with the 37 and 62, either of that. Now you can see that 17.9, 20, something like that. What is our directive is that mass loss should not be more than 30 milligram per square meter. So we confirm this requirement. I don't know on the back whether the this photograph is clear with you all, but this is a crosshatch test, which is very commonly done for the adhesion test. Now you can see this is the, and we it passes 4B, classification. And salt spread tests. These are all these tests. What I'm showing it to you in India, nobody used to perform maybe 1 year before. So nowadays everybody is talking. So we are all gearing up to service the industries. Here we see this. I think 512 hours, and we didn't get any corrosion bits. Well, don't get afraid. Cast test on anodized aluminum. Now here what we have done it is cold sealing that specifically designed cost nickel based system, and we get up to 24 hours. There is no corrosion pits. This is the dual sealing system. First is the cold sealing and then hot sealing. This also gives a good. But if you do the duplex sealing, you will be able to influence much better. Here, very interesting test. We have done this the red colors, and today I see that lot of requirement of this type of red coloration. This is the immersion dip system, and here what test we have done it is 0.5%. This is NaOH solution. We put a droplet, and we see the parts after 24 hours, because we all know that alkali leaches and reacts with aluminum. So this is the alkali resistance test we have performed, and we get very interesting results. This is the color fastness test. So normally after producing the parts, exposed to the xenon arc lamp with an UV filter with a 300 to 400 nanometers scale, and see the change of the color appeal. And what we saw, that one of our stuff, that is a green, didn't qualify, and we see the visually there is a change, and also the LAV value is also found to be a lot of change as the control sample versus the exposed sample. But the rest of the other things what we have tested, it has passed by approximately up to 888 hours. Here also what we have adopted a philosophy is duplex sealing. It's a cold sealing and followed by a mid temperature sealing. So with this I conclude. Thank you very much for listening, and more so about bearing with me in the interaction. Thank you.
Thank you, Mr. Subrato,
Thank you, sir.
for elaborate information on anodizing. Please spare 2 minutes. We would like to give you a memento from MFAI.
I want to be with him, my good friend. Thank you. Thank you so much. My pleasure to do this. Thank you. Thank you very much.
इसको रिटर्न करना है, आपको पहले दे चुका हूँ. Now we start our third lecture. Our speaker is Dr. Klaus. He holds a PhD in natural sciences and presently working in McDermott Anthon Industrial Solution as Director of Global IP Management. He has got more than 20 years of experience in research, technology management, and executive leadership. I welcome Dr. Claus. His topic is quite interesting. How to save.
Yes.
Have you given your presentation to them?
Yes. Yeah. I sent it. Okay. Good. Oops. Okay. Good. All right. Perfect. Yeah. So thank you very much, Mr. Chairman, for the introduction. Also, thank you everybody for attending this session. Before I start, I want to apologize. My voice is very low. At home we have snow, and here we have 30 degrees. So the temperature change did not do very well with my voice. But I will do my best to go through these slides. Yeah, my topic is energy and water saving in electroplating plants. First, I want to give you some background. So this is global energy consumption and energy production. How do we produce the energy? We see that especially in the emerging economies, India and China, the energy consumption is going up a lot. Uh, and that correlates with BIP growth. So in the old economies like US or Europe, we have more or less a stagnant energy consumption. In European Union. Even in the recent years, we have a slightly lowered energy consumption. The good news is the renewable energies, they are on the rise everywhere. But that said, the best energy or the greenest energy is the energy that didn't even have to be produced. So the energy that we save. In terms of water, the situation is a little bit more complicated because water is a primary and natural resource, but there are calculations or there are statistics on the water withdrawals versus the water resources. So the water resources would be the fresh water in a country's lakes or rivers, which are naturally replenished. And yeah, here we see that there are obviously some regions in the world where fresh water is critical. Especially in India, of course, we know that this is more a regional a problem in a big country like India. It will always be more regional problem than a national problem. But this is how the statistic works here. Electroplating by itself is by nature a very energy and also water intensive process. So already in the word electrolysis, you can see there's electric energy in the word, and then there is some kind of solvent in the word, and in the industrial reality, that solvent is water. So water and energy is important for electroplating. And then around that, there are peripheral processes, rinsing or drying and heating, heat treatment, which are also very energy intensive. So I don't have very new numbers, but I think these numbers might be more or less still representative. So in a typical plating shop, we can say that up to 10,000 megawatt hours of energy are used every year, and also more than 50,000 tons of water. So that's quite a lot, which means also that there's a lot of saving potential. Here again is a breakdown. On the top, you see a breakdown for general electroplating, and then on the bottom, you see a more detailed breakdown for zinc plating with some more detailed categories. Yeah, big picture is what you can see. The rectifiers and anything that has to do with heating are the biggest contributors. Okay, so that was energy again, but then let's go back to water. So I will switch back and forth between energy and water in my presentation a bit. I hope that you can still follow. I will start with saving water. And what we've just seen, the big contributor for freshwater consumption in electroplating is the rinsing. And that's a common knowledge that good electroplating is not possible without good rinsing. And if we want to save water in rinsing, then we don't want to we don't want to rinse less, but we want to rinse smarter to get the same result with less fresh water. So most simple case of rinsing. So I do a little lecture on rinsing. So I will try to make it fast. So the most simple case would be a single freshwater rinse where the used water of the rinse is somehow recycled or reused. It's very clear that if you want to have a good rinse result and a reasonable water consumption, that concept is not going to work. So what we want to have is at least a multi-stage rinsing process. Here, again, a very simple case where each of the rinses get a fresh water supply. That's also not electroplating standard. But what we are doing is, of course, a counterflow rinse cascade, where only the last critical rinse gets the fresh water supply, and then the earlier rinses get the fresher water from the later rinses. So that's for anybody working in an electroplating plant, this is common sense. But even at the university, if you ask an electrochemical professor about this, he might not know it. So it's important that we keep in mind these basic principles. Yeah. So then, how much fresh water do we actually need? And that is something that can be controlled, for example, by a parameter like conductivity in the last rinse. And then we might need more or less fresh water based on the part. So a simple part like this might need less fresh water, whereas a part which has higher drag out, you will see the conductivity going up in the last rinse, and hence you will need more fresh water in the rinse. The part geometry is only one element here. So another element for another contributor for drag out is the active electrolyte itself, and then also the drip time. So whether we have, for example, a cleaner or an electrolyte, so the density, the viscosity, all that plays a role here. And then, yeah, there's another factor. How clean do we even need the part to be? And then there's something that we call a rinse ratio. So how much of the active bath that the part is coming out from is still on the part compared to rinse water, fresh, clear water. And here also there are recommendations from plating associations like our German DGO, for example. And And we see that active baths, like decorative plating baths, they need a much higher rinsing ratio than, for example, pre-treatment baths. And it's again something from the DGO, from our organization in Germany, where there was a calculation was done how much fresh rinse water do we need in a rinse cascade based on the number of steps and based on the rinsing ratio that we want to achieve. And here you can see very clearly adding a step is always very helpful. So if we have, for example, if we are a nickel plater and we need a rinse ratio of 10,000, then just adding one more step, so going from 2 steps to 3 steps, will reduce your fresh water consumption to 1/5. So yeah, just some more concepts for rinsing. Of course, there are other things that you can do, like a rinse cascades with a spray register. So why pump the valuable cleaner water from the earlier rinse directly into the next rinse bath? So what you can do is you can just use it to spray the bath, spray the part only if it's coming out. So that works like this. The part is coming out, and only then it's being rinsed with this fresh water from the next rinse. Like this, and then, yeah, for the next one. Yeah, just one last concept talking about rinsing. Is the static rinse. In Germany, we call it Sparspüle. So it says that it's saving us something. And what it does, it saves us fresh water, and it also saves us active electrolyte, because this static rinse will eventually, in the equilibrium state, will eventually have a 50% water and 50% active electrolyte. So depending on the process, what you can also do is you can replenish your active bath with this static rinse water, which has 50% of your active ingredients. So of course, it depends very much on the process if that's possible or not. So all these concepts can be combined, and obviously you need to rinse after each active step. So in the end, you have a lot of baths, but here I just drove this to the extreme here. If you do all these steps, if you can replenish and reuse rinse water, if you can then even recover your evaporated water from the rinses or from the baths, then you can think theoretically on the way to a closed loop electroplating plant. It's where you could eventually plate in a space station if the water would stay in the rinses. So yeah, we have this is something for a single bath, for a single active bath. We use a little calculator in our company, where depending on the active content of the additives that you use to replenish your bath, and based on the rinse concept, you can see that if you have a overall evaporation loss, or if you have a solution growth. So solution growth, as we know, can be a big problem in some electrolytes. And with concepts like this, with calculators like this, you can estimate that. So just going through this. So just different scenarios, different chemical concentration, or here a different rinse concept, like this static rinse that I've just introduced. Here's something from the literature, already pretty old paper, where this evaporation calculation that I just showed you for a single bath is done for a rinse cascade. And so only maybe one take-home message. What they did is, can I go to a completely water disposal free scenario? And yeah, I can. but that depends on the evaporation rate and also on the rinse rate, again, on the rinse ratio that is required. So if I want to have a high rinse ratio, if I have a strict rinsing requirement, then I need also pretty high bath temperatures in order to get these high evaporation rates, which again is a problem then for the energy saving that we want to do. So it's all a give and take. Yeah, so these were all examples for plant design for parameters for the entire plant. Now, if we go one level up, then we come to hoist scheduling, and hoist scheduling is a completely different game, because here we are talking about a non-linear problem. So what part or what rack, what barrel is going into which path when is a quite again a quite complicated mathematical problem, and the simulations or calculations to optimize for minimized freshwater consumptions were not even done before 2004. Yeah, I will only go very quickly into this. So there, yeah, just show this one example from this paper. And there are some interesting things that you can find out here, like it's possible to improve your rinsing result or to reduce your freshwater consumption by measures like staying in the rinse for a longer time. If that's possible in your electroplating sequence, or with the process and with the deposits that you're working with on your part. But yeah, it's possible. So if you can do that, if you can stay longer in the rinse, and if you can program your hoist accordingly, then you can save some fresh water without even lowering your throughput or your cycle time. Yeah, there's again coming back what we are doing in Europe or in Germany. There are currently EU-funded projects to work on such topics and to reduce wastewater, but also to reduce freshwater consumption. So here you see quite a big project, 10 million euro EU funding. So this was all about process optimization and how to run your electroplating plant to save energy and water. We, as a chemical supplier, obviously, we see another side of the medal, and that would be, can we also reduce water and energy by using the right processes, the right chemicals, the right additives? And yeah, that's our job, to develop and to sell water and energy saving concepts and also additives. So again, starting with water. So one example is the reduced iron electrous nickel. So conventional electrous nickel works at 6 grams per liter. Then we have a reduced iron series of EN processes that works at 3 grams per liter. So at least half of the nickel drag out. And what you can see is just that the dissolved solids, so everything that you will have to rinse off your part after you were in the EN bath, are drastically reduced. So if you compare a conventional EN bath with a reduced iron EN bath, then the difference in dissolved solids is comparable to beer versus fresh water. So I think that's quite impressive comparison. And yeah, again, you can improve your rinse results or use much less fresh water when you use a process like that. Now coming to energy saving and CO2 footprint that we've also heard about in the first presentation. Here is a classical zinc plating sequence, cleaning, plating, passivation, and sealing. There will be another presentation from our company later today by Mr. Sandeep. And that's why I will not go into detail here, but I will just focus on the fact of energy saving, how you can save energy in all these steps. So in cleaners, for example, you can use a low temperature cleaner, and you can save already some energy here by using a low temperature cleaner, not having to heat up your cleaning bath. Then there are zinc nickel processes, and you can lower your energy consumptions by having a more efficient bath, also having a lower cell voltage by using membranes. And we have this 3S concept, 3S membranes, and we have a lot of real world numbers that show you how much energy you save here. So that's hard numbers. Passivation, there are also higher and lower temperature passivations. And that's also something like with the cleaners where you can save a little bit of energy. Then the sealers. So there are still applications, high-end applications where you want to use, maybe you want to use curable lacquers, curable top coats. But then if you have just a drying top coat, which also gives you a very high very high performance, then you can also save a lot of energy in comparison as if you would use this curable lacquer. That's the total calculation here. And again, these are really hard numbers. You can save, cannot go into detail, and there will be later another presentation about this topic. But yeah, you can save quite a lot of energy. Okay, perfect, because this is now my conclusion. Again, you can do a lot of process design, even in things like hoist scheduling. But we believe that the true energy saving, the true freshwater saving are done with good, smart, and innovative chemistries used in electroplating. Thank you very much.
Hello. Thank you, Dr. Claus, for a very interesting topic on the conservation of energy and water. We would like to present you a memento. Excellent. Excellent.
Yes, thank you. Thank you. Yeah, thank you.
Yeah, thank you.
Oh, yeah, it's a souvenir.
Souvenir.
Okay, soft copy. Of shopping. I have 2026. Perfect. Thank you very much for you. Thank you. Thank you.
Right.
Thanks.
Now we move on to our fourth session. Uh, and our speaker is Christoph Redman from AUKUS. He's a mechanical engineer and he has got experience in the field of planning and design of electroplating lines. Along with him, Mr. Florin will be assisting him, and his expertise is in artificial intelligence. I welcome them on the dais. Please.
Yeah. Thank you very much for the introduction. and I'd like to welcome you to our presentation about application of artificial intelligence-based production simulations for planning and operations in surface treatment. My name is Christoph Redemann. I'm from the Aukos company, and we split our presentation today in two parts, and the second part is done by my colleague and CEO, Florian Wimmenauer. Yeah. Yeah, the company Aukos was founded in 1979. Our headquarters is located in Aachen, Germany, and we are specialized on control systems, on software solutions for control systems in the plating finishing industry, plating finish industry and surface treatment area. We have worldwide over 75 employees, and we provided over 2,500 control system solutions in different kind of industry areas. Okay. Okay. Yeah. Good. Yeah. Over that time, over the many projects we had one major learning about surface treatment, that the surface treatment industry is constantly facing changes and new challenges. Yeah? And that can be driven by very different kind of factors. Yeah. For example, by new regulations for use of chemicals. Yeah. By the treatment of wastewater. Yeah. We learned from our recent presentation about energy consumption and use of fresh water. Yeah, that's good. Now I'll go back a little bit. Yeah. Fresh water, energy consumptions. Sometimes there's also the issue, how about availability of operational staff and workers, yeah? And from that, we would like, we assume that there are several questions coming from, yeah? And today we would like to provide we would like to pick a few of them and provide our answer to, yeah? The first one is how production requirements are changing. The second one is what role does plating play in day-to-day scheduling in the production, and which possibilities can modern software offer to allow a comprehensive scheduling. And one major requirement in production is that the number of parts, the number of variations of articles and products is rapidly increasing. Yeah, every continuously new products are coming to the market. Yeah, new variations of existing products are on the market. While at the same time, sometimes also the existing projects are still available to buy. Yeah, and that puts a lot of and that has to be matched somehow with the production. Yeah, with the manufacturing and production. And also on the other hand, the point is that the lead time for new products is much shorter. But that's also clear. Today we have CAD simulations, product simulations, so it's much easier today to get a new product on the market. Yeah, we talked about I talked about a customer here. Talked every 3 years a new car is coming up. Yeah, every 2 years a new mobile phone is on the market. Every new year a new coffee machine. Yeah, and that is a rapidly decreasing time for new products. Yeah. And on the other side, the number of lots is reduced. Yeah, while before maybe 100 parts of the same time had been produced, while the manufacturing process is now in a situation where they have to produce 100 different parts within the same timing. Yeah, and that requirements for production are sometimes also very contradictory. Yeah, you have, for example, in a manufacturing process, there are storage shelves, stocks. Yeah. There is transportation needed to the customer, but no one is really able. No one would like to pay for that. Yeah, But on the other hand, you have the just-in-time delivery, which is required by your customers. And that is sometimes a very challenging thing to combine. Yeah. And then there's also the surface treatment line itself. It's a very complex system. Yeah. On the surface treatment lines, you usually run many different kind of maybe different kind of recipes with different steps, different timings. Yeah. Also different finishing sometimes. Yeah. 2 minutes etching, 5 minutes etching, or an anodizing line, 20 minutes anodizing, 40 minutes anodizing. So that is a very large range of products. And you would like to have, at the same time, while running this different product, also a good quality on the parts. You would like to have it also constantly. If you run your product on Monday, for example, you would like to have the same quality if you run the parts on Thursday or Friday. Yeah. And also the production volume is there that needs to be matched. Yeah. And that makes it very complex. Yeah. And there's also a lot of management around. Yeah. The REC management. There is a management for the wastewater treatment, for the chemicals, for the dosing. There's also a laboratory that needs to be managed. Yeah. And on the other hand, there is the service needed for the line. Yeah. Tanks need to be serviced. The hoists need to have service and maintenance. We have service for the site equipment. So that needs to be somehow managed and makes it very complex. Yeah. And the plating line itself is usually not a single part of the production. Yeah. Usually there's maybe a line with several finishing. It can be also that there are several plating lines in the same factory that need to be somehow managed. Yeah, with different kind of products. We have processes where there is maybe zinc plating up front. Yeah, and then there's an e-coating afterwards. Yeah. So you have to scheduling how the parts coming from zinc plating to the e-coating without any interruption of the process and production flow. Yeah. And the plating line itself, is usually integrated in downstream and upstream operations in the production. So, for example, we have up front of the line, we have the loading operations, provision of materials, logistics, and downstream of the plating line, we have the unload operators, we have the quality inspection, and what we see right now that loading and unloading, for example, is still driven manually, and that is something that may be changing in the future to automation. Yeah, there's a huge potential for automation in loading and unloading, and also for quality inspection. Yeah, so this is an additional factor that is coming in. Yeah, and taking all this into account creates a very complex model. Yeah, and today with existing calculations, the best choice of parameters and variables can be found, but it takes a lot of calculation power. Yeah. So what is usually done, reduce the complexity of a mathematical model. Yeah. It can be done by reducing the variables or placing rules. Yeah. To reduce the number of independencies between variables. Yeah. And the results out of that calculations can be also sometimes not very flexible and are rigid. Yeah? And the operators and the dispatchers in the line, what they do it on experience and mutual feelings. Yeah? They have an intuition for that. Yeah? And that is the situation where modern AI, artificial intelligence system, can come in, because now the artificial intelligence is able to map and anticipate the behavior, like experience, mutual feelings. Yeah? And if the conditions and boundaries of a model and the expected outcome is defined, the system itself is able to learn, and improve itself over time. Yeah? And that is now the point where I would like to hand over to my colleague. Yeah? He would like to go more into detail about that. Yeah, please.
Can you switch this on? Hello? Okay. Thank you. It's okay. It's okay. So yeah, let's have a look at a few numbers. So we already talked a bit about complexity, and as already the speaker in front of us before us as well said that there are mathematical models to kind of compute the optimal solution for certain things. here you actually do see a thing where we actually only want to compute the best order of a few work bars going through a line. And here you see that on the left side, we have the possibilities that when you are down with like 4, 6, 8 work bars, you have very traceable possibilities. But due to the exponential method of this, or exponential problematic here, with 10, you're already at the 3.5 million possibility thing. And I mean, eight parts, that's nothing for any of our lines. So if we look at a daily production, we have easily more than 100 products in there. And if we want now to just check the best way of getting our 100 products through the line, we would now need to compute every possibility how we can match them. And now, if we only want to take from these 100 on the right side, you see the chart, we now have 100 parts and we want to take the best next 4. You see, it's very little computation. But if you go more, on the right side with a 10, you see we are there somewhere in the quadrillions of possibilities in there. And if we just make for scale, if you would see our few million possibilities, if we just have a left side, it's somewhere very low on the right side. So we see that just by looking at these huge numbers, that it's already very complex to calculate the compute area. And just from the computational side, so these experiments were made on a normal MacBook Pro, so nothing all too fancy. And if we have a sequence of 4 products, it takes less than a second. If we have a sequence of 6 products, it takes already 6 minutes. If we have 8 products, we are already on theoretical 6 days. And if we only want to make a subsequence of 10 products, if we do it the complete way, it would already be like 130 years. And nobody of us can wait so long. So what is actually the main capability of these AI models we have? It is that the evaluation of what is a good schedule and what's a bad schedule gets better and better. So with these systems, we can not only check the order, what we had to look earlier, how complex it is, but we can integrate the loading capacity available. We can as well have a look which raw material is there. We can as well have a look what will be delivered soon to the line. And then as well, there are the parts within the surface treatment. So basically, which racks are available if we have specialized racks for certain parts? Or does the project match, the process match? Because as you know, we always mix processes in our lines. And then when we go further, as Christoph already said, we as well want to integrate into our planning or into the consideration what is a good part to produce. Do we have package material? Do we have people to unload? Or do we as well have QS people to check for quality? And all these things we can nowadays evaluate in one of our digital twins. I mean, that's basically a standard. But there, again, if we take a traditional approach, we would have a single schedule. We looked at the numbers before. We can evaluate a single schedule in 0.1 seconds. 10,000 simulations, we are already at 1,000 seconds. And when we want to do the simulations for all of our 100 work bars, we are already at 100,000 seconds, which is something like 27 hours. So only for one thing, we would already need more than a day to simulate the best options. So what do? We have here on the left side a decision tree, because basically the problem is nothing else than always selecting which part we should go next. And then we see here on the left with a big red dot, we have a lot of options to go further. And to evaluate these options, these plans, we throw everything into a neural network. So you all heard about the advances in the ChatGPTs and something like that. So we as well have something similar to this, but developed specially for surface treatment lines. So we can put in all these factors, all the line parameters, and with this get basically a score of a plant. And this makes the system able to compute very quickly and very efficiently an optimal sequence for mixing products in a line, and as well, if needed, to look at the upstream and downstream parts within the production system. let's have a look at a few results. So here on the left side, we see a traditional approach. I think it is a delivery date first approach, which a lot of people, is very common in the industry. So to explain a bit the graph, you see these darker thick lines are the production times while a part is in our surface treatment line. And the whisker with the bar to the left, most likely to the left here, is the scheduled delivery date. And as you see, if we have very, very tight dates, it's really easy with such a method to deviate and have always larger growing delays or tardinesses in the deliveries. If we throw this through an AI model, these are the exactly same data. If we have now our 100 parts, we still might not match every single delivery time in this, because this was really an example where it's extremely tight in the delivery areas. But you see that most of the delivery times are matched. And what's more interesting even is that we are way faster done. So on the y-axis, you basically see the cycles which we need in the surface treatment line to produce these 100 parts. And on the right side, you see we're way lower, and about, I think it was 106 cycles we are done with all of these. But like the order and these things are just one part. Which is as well nowadays always very interesting, is the quality, because it doesn't help if we can produce very quickly parts which are all faulty. It just gets expensive and doesn't help anybody. So what you see here is the monthly percentage of bad quality for a customer which we had. You see on the left side is still the startup period. So there, the complete line was kind of running in, but we put this as well in there. So if you see on the right side, it's actually okay. It's around like less than 1% of faulty parts a day. It's mostly depending on how expensive your parts are. A lot of customers deem this as acceptable. But if we look deeper into one day and split it about the hours, we again see that there's a peak. And obviously, peaks are always easier to detect and to reduce. So what we did is we trained as well an AI model, which we specifically developed for this part, and are able to predict the quality throughout the process. So here on the Y scale, you have an F1 score. It's basically the certainty of an AI model, and on the X-axis you have the steps. And you see that it's not that the F1 score is not continuously increasing, but makes steps. And when we then looked at it, it's actually pretty simple why it makes steps, because some process steps are more quality dependent than others, or more quality changing than others. And on these blue things around, you see as well the confidence of the model. And with this, we can predict the quality of a part at any given time in the line, and as well before even the part enters the line. And if we merge these two things together, that we have the scheduling, like what we want to mix, what parts, what components we want to mix, how to put these things together, in addition to the knowledge and the trained models for quality, we can achieve very densely packed schedules with high quality output to reduce the problematic things there. And yeah. So to conclude, with AI software, it is now possible to not have to make like assumptions or like to simplify problems, but that we really take the core of the problems we have every day at hand and learn these. So this as well means that we don't have to always come back to reprogram something, because the models can adapt if the line changes, if the mix changes, if the quality changes, if somebody goes for different chemistry, which we don't hope. Then all of these things can be adapted. So we can always then as well there kind of learn with the lines. And always the question is about automation, what to do with the employees. Obviously, sometimes we want to reduce the number of employees, but they as well have time for different things. So it can as well be utilized more, and we can use the manpower as well in a different way. But as well as for everything in surface treatment, there's not one unique solution. So for everything, we always have to really check how the structure of the line is, what the specific needs for the customer are, and then we come up or build together a system which is specific for this customer. Yeah, this was already this. I think we already had a few minutes earlier due to this. So yeah, thank you very much. We are at booth F101, so you go here and then right. So if you are open to talk, we are there, and just drop by. We would be happy to welcome you. Thank you.
Thank you, Mr. Florian and Mr. Christoph, for a brief introduction of AI in the field of metal finishing arena. Thank you. We go to our next lecture. The next lecture is from EPI. Mr. Eric Olander is going to. I welcome Mr. Eric Olander. His topic today is elimination of cyanide strike silver and then the use of non-cyanide silver plating. He is a science graduate, chemical engineer, EPI president, on NASF Surfing Committee chair, MFSA board of directors. I welcome Mr. Eric Olander.
Morning, everyone. First of all, namaste. I'd like to say thank you for the opportunity to give this presentation. Before I get into the actual presentation, I want to give you a little bit of history, how we got involved with non-cyanide. First of all, EPI, our company, was very big in copper plating. And we said we got to come up with a non-cyanide copper. So we started doing that in the middle 80s. So we had very good success with the non-cyanide copper worldwide and in the United States. But then what happened, a lot of our customers who used non-cyanide copper also wanted a non-cyanide silver. And the non-cyanide silvers that were out there at that time weren't very good. So we developed one and that took off, and now we're on our second generation of non-cyanide silver. So purpose of today's talk is talk about how to eliminate the cyanide silver strike tank and plate directly to copper, copper alloy, and nickel with alkaline non-cyanide silver. This can save you a lot of money because you don't have to have a strike. There's some panels with the pictures on the copper, on the nickel. So what do people plate silver for? First of all, decorative. Here, when I'm walking through the trade show here, I see many decorative applications of silver. Silver is a big use in India for decorative and silverware. Electronic switches and connectors. And the thing that's really changed is data centers. I don't know how it is in India, but where I live in Wisconsin, they're building a lot of data centers. They're actually going to build 3 more power plants that power the data centers. So a lot of opportunities for silver plating. And biggest is bus bar. I mean, some of this bus bar is getting up to 3, 4 meters long. So how can you plate silver chemistry or silver? You have two ways. One is non-cyanide silver and one is the silver cyanide. Silver cyanide's been used for a long time. It's a great workhorse, has various brighteners, selenium and antimony, can give you hardness. It's a workhorse. The only problem with cyanide silver is you got to have a strike tank to make it work. Non-cyanide silver technology doesn't need a strike, so it saves you some real estate and actually saves you some money as well. So how do we design the chemistry to make it work? You got to look at various complex agents. You got to look at friendly chemicals to the environment. You don't have another chemical like cyanide that you have to worry about in waste treatment. And then you need something that'll let the silver be precipitated out easily, so something that won't so tightly bond to the silver. So that's a big challenge in your formulations. Then the next point of order is we say we need a bath chemistry. A lot of non-cyanide silvers we first developed, they get underneath these lights, fluorescent, they would break down over time. So you need light stability with the chemistry, very, very important. Our first process we had could plate over nickel, but it was very difficult. You had to use a cathodic electroclean. A lot of people don't like using that. So we didn't really say we could plate onto nickel, missed a lot of opportunities. So we've been working on developing a newer technology that plates onto directly to the nickel, which does a great job. So one of the requirements obviously is excellent adhesion. And we'll talk into more specifics. One thing that's very interesting with this latest technology, it's a whiter silver. It's about 99.1 to cyanide silver when you use the color computer that they use for paints. So it's almost a match. Other non-cyanide silvers have a slight yellow hue, including our first one that we developed. So the breakthrough with this technology in the formulation was we can plate on nickel, which was our biggest challenge for the last 20 years. But then you can also do copper alloys as well. Developing stable chemistry, our tank solution that we developed 7 years ago is still in the tank and it still works. A lot of non-cyanide silvers don't do that. This chemistry is very, very stable. Our first chemistry is a lot more unstable. A bright silver for electronic industrial decorative applications. It plates out of the silver anodes, so you don't have to add silver concentrate back, so it'll save you some money. Recovering power and throwing power is exceptional. It's better than cyanide silver. We had one customer who had a bus bar or a bracket that was like an L bracket like this, and they had to get in this deep recess area just to get silver coverage. And when they plated with cyanide silver, it would take too long to get this silver in there versus non-cyanide. All they needed was a flash. So they went to non-cyanide silver and they saved a lot of money on metal costs because it covers faster and quicker than cyanide silver. The deposit's a fine, smooth grain, dense with low porosity, brilliant white, and I said anti-tarnishing properties because of the chemistry and the color and the organics that are used. It has better anti-tarnish properties. And one thing that's very important, when I say room temperature, that's back in the United States. That's like 20 to 25 degrees Celsius. So here in India, you're going to need to chill the bath. Okay, US, it's cold, so we can get by. But tarnishing, definitely need chilling here in India. So here's some specifications. So you can see the metal's low. We're about 9 grams per liter up to 1.7 pH. We use potassium hydroxide to bring up the pH. We'll talk more about that later. There's the temperature range. The lower the temperature, the whiter the silver. Cathode current density, that'd be 0.3 to 1 amp per decimeter squared. Current density, 2 to 1 amp per decimeter squared. So what can you use? Slab anodes work well. Popcorn silver. Some of my customers are going to the polypropylene baskets with a titanium sparger or it's like a knife. It goes in the middle of the basket. That way you can use popcorn silver. Got to calculate your anode to cathode ratio about 2 to 1. Filtration is very important. If you're not going to filter the bath, you're going to have issues. So you need to filter it with 1 micron. The first chemistry we did, we used continuous carbon filtration. And you change it, we treat it like a bright nickel. I mean, when you plate with cyanide, your operating window's like this. Non-cyanide's like that. Non-cyanide's needs filtration, needs carbon filtration, and it's sensitive to some contaminants. Cyanide's a great cleaner. So as long as your customers are willing to work with the parameters of non-cyanide's a great way of getting rid of the cyanide from your facility. The thing that's most important about that is having the upper management support the production team to make that happen. And then, of course, we've got air agitation. Air agitation is very important. It helps give you a brighter range. Kind of acts like a brightener. So this is how we make up the bath. We sell these as liquid concentrates. The liquid silver concentrates are made up at 30% by volume. The maintenance electrolyte is like your cyanide in your bath. It complexes the silver coming off the anode, 30%. The brightener, that's at 1%. And the rest is deionized water. So that's a typical bath makeup. Sometimes you can adjust for higher metal, but this works good. So as I said, the liquid silver concentrate provides initial silver ions, and if you need to replenish it, maintenance, electrolytes, complexes the silver as it comes off the anode. Will help dissolve the silver. If you don't have enough electrolyte, you won't dissolve the silver well. And then you can also check adhesion between silver and the nickel. What some customers do, or we teach them to do, is you can plate with a hull cell, plate your nickel on the hull cell, and then take your silver solution and plate that on top of the nickel, and then do an adhesion check by bend test of tape. It's kind of like an inexpensive IC or HPLC. So the adhesion, and we also use the tape test when we're doing that too. The brightener refines the silver grain and controls the crystal structure as most brighteners do. So the maintenance of the bath. Silver metal titration, you can also use ICP if you want, or X-ray. Both of those work. Again, the silver metal's supplied from the dissolving of anodes, so what that does, it saves you metal, saves you money, instead of buying expensive chemistry from us. The maintenance of electrolyte, there's a hull cell test for adhesion where I talked about the tape test and you bend the panel. HPLC analysis, works really well. And then we set it up by amp hour basis as well too. The brightener, as most brighteners are tested with a hull cell and ICP analysis and based off of amp hours as well. So the pH, we want to keep it 9.5 to 10.5. Lower the pH with nitric acid. In all my years, 25 years, I think I've only had one bath that I've ever had to lower the pH. Raising the pH is definitely a lot more common. When you make it up, you got to use potassium hydroxide when you first make it up. Continuous filtration, 1 micron filter that helps picks up the particles and gives you a nice smooth silver deposit. Our first non-cyanide silver we came out with, one of our customers actually used a 0.5 micron filter, and he actually found out that he was getting nanoparticle size quality of the silver deposit just from the filtration. So that leads to me to believe that filtration is very important. And then air agitation, as I talked before, will give you a brighter range and higher current densities. That's a high volume, low pressure blower, which is used out in the industry as we do today. I don't know all the specifics of this is done by my chemist, but this is to show that the HPLC, if you look to the right, there's the peak measuring the electrolyte chemistry. So since we can measure this peak, we can figure out how much we've got exactly in the bath. Again, it's not necessarily required to have a nice HPLC to run the chemistry, but it helps. Current density will plate as fast as cyanide silver, but these are the numbers. I won't get into that. It's pretty self-explanatory. Here's an SME picture for you people, metallurgists who like SME pictures. It's 500x magnification. You can see the grain structure of the silver. And here's the cross section over nickel. There's the base substrate, then there's nickel, and there's silver on top. The silver is kind of the black. Kind of looks like copper. There's a copper. That's the way that when they did the cross section. So communicate. Let's talk about some properties because everyone's interested in what's available and what it can do. Purities is 99.9%. The hardness 150 to 200 Vickers hardness using a nuke diamond. The brightener helps or will increase the hardness of the bath. Electrical resistivity is very comparable to cyanide silver, about 3 microohms per centimeter. And then we did a wear resistance test compared to cyanide. The test performed by Tabor reagent. Tabor reagent is the thing that they usually test for paint a lot, organic coatings, but it was able to break the silver deposit. Was a great resisted wear better with a non-cyanide versus cyanide silver. Alrighty, here's our conclusions. Silver deposit is a bright white color and shows anti-tarnishing properties in other non-cyanide silver processes. Please note we do have some of our customers that will still wrap the silver in silver paper because they want long-term protection. New chemistry is very cost effective and it plates entirely out of silver anodes, again, saving money. The stability of the bath compared to other chemistries. pH of the solution is buffered and remains stable during plating and when idle. That point of order of when idle is important because if some of the platers here will only plate once a month or once a week, that's very, very important. So since we can plate directly on the nickel surfaces, we can meet all 3 types of the ASTM B700. That's the spec of plating on silver on nickel. And so you can save money because you don't have to put a separate silver strike on these like the cyanide silver. Plating bath is alkaline, cyanide-free plating solution which can plate bright silver for electronic, industrial, and decorative uses. I think that might be it. Thank you.
Hello. Thank you, Mr. Eric, on your lecture of eliminating silver strike, cyanide silver strike. Very good lecture. Good innovation. Yeah.
Thank you, Aman Phatak Sarji, to conduct this session. Token of the appreciation from the MFAI. Please go. Friends, now we will take the small 10 minutes tea break. Please enjoy your tea, sir. Please.
Hello. We start post tea our session. For this session, we have chairperson Mr. Florian. Is a MSc in artificial intelligence. He is working with Ecos as CEO, as a software engineer with several years of professional experience and extensive expertise in the field of artificial intelligence. Florian has been successfully managing the software company Ecos AG in Germany since 2024. I welcome Mr. Florian on the dais. Thank you.
Good morning, sir. We're glad to inform you that our Air Force person, please come, sir. I think एक ही है. Please call your colleague, sir. Pathak, sir.
So our first speaker is Mr. Kalai Praveen. He is the Vice President of Rono Group with over 25 years of electroplating experience in diverse industry segments. He worked for key multinational and Indian companies, Antona Surface, Grauer and Weil. Please welcome him to the stage.
Good morning, ladies and gentlemen. Today we'll be talking about the trivalent chromium processes for functional and decorative applications. To start with, we do know what are the industry segments where the hexavalent chromium is currently being used, and slowly the transformation towards trivalent chromium is going on. Why we would like to change is basically because of its hazardous nature, carcinogenic, and labeling in many countries, and highly polluting hexavalent chromium. We would like to get away from that. So what are the options? So there are some options which are like paint systems, some PVD based coatings and lacquering type of coatings, and most predominantly and most suitable product is the trivalent chromium plating. So why trivalent? So this has lower occupational hazard and acute toxicity rating compared to the chromium trioxide, which is chromic acid. And especially this process does not give carcinogenic mist, which is very common in hexavalent system. And no PFOS materials are being used in the any of the additives, nor in the and there is need for any mist control in this process. So the types of chemistries available today with us, predominantly sulfate is the widely used chemistry in the industry, but we do have some very good processes in chloride based system, which is Tri-EcoStar 3000 and 7000 series. Whereas for sulfate base, we have Tri-EcoStar Ultra Chrome, which is very good for comparing the color with hexavalent chromium. And the newly developed processes are Tri-EcoStar Sapphire and H, which are for barrel and hard chromium plating respectively. For decorative applications, the commonly used processes are 3000 and 7000 series along with Ultra Chrome. Whereas for functional applications, we can use Sapphire, but predominantly it is Echochrome H. We'll be talking in detail about the individual process in the forthcoming slides. So the differences. Comparatively, sulfate-based chemistry gives a very good whitish color comparable with hexavalent chromium, and the process controls are pretty easy. This was the uh, process which has been established for quite some time now, and the corrosion resistance is also relatively higher. No cooling required due to the operating temperatures and no temperature buildup. And most all the all the additives are liquids, so easy for the dosing and handling of the workers. So the why we would like to use chloride-based systems is the speed is pretty much higher than the sulfate-based systems, and the anode system is simpler, because normally in sulfate-based systems we need to have the MMO-based anodes, which are quite expensive, and particularly in India we do not have easy availability. However, this process being pretty popular and easy to control, still a majority of the systems operating in India are sulfate, but we as Ronak, we are pushing more of the chloride based systems because of simpler anode system, and also the life of the anode is very high. We generally use graphite anodes, so easily available and long durability. And in the chloride based system, we are also offering the color variation. So we can have the exact hexavalent finish to a dark black finish. You will be seeing the different finishes in the forthcoming slides. So this also is highly corrosion resistant, but compared to sulfate based system, this has an additional advantage of giving positive results on the Russian mud test. So the anode system, why we need different special anode systems, is basically to avoid the generation of hexavalent chromium during the electrolysis process. So in the sulfate system, we definitely need the mixed metal oxide anodes to avoid the hex chrome formation. Whereas in chloride based system, we can use graphite as there is no generation of hex chrome. So ion exchange system is one of the key equipment which is needed for trivalent chromium based systems. The reason being this being a very expensive chemistry and multiple additives and even the metal compositions, because as we all know, this is not a pure deposit. We do have some alloying material. So this is very sensitive to contamination. So at Ronak, we do provide the recycling, the ion exchange, wherein we can purify the bath, and also we can even recycle the chromium back to be used in different applications. So coming to individual processes, TriEcoStar 3000 series is specially used for applications where we are looking at just a chrome based finish, single color. The plating speed is very good, around 0.1 to 0.15 microns per minute. The productivity is good compared to the other systems, and the reject rate is less. Color is very close. However, the ultra system is much better than this, but however, this is also quite close to the hexavalent chromium finish. This also has the Russian mud test positive. This passes the Russian mud test, which we talked in the previous slide. The low current distribution is also very, very good. So the uniform color as well as the thickness distribution is possible in the chloride based 3000 and 7000 series. Coming to the ultra chrome, this is even though this is a sulfate based system, this gives the best color when you are comparing to the hexavalent chromium based system. So deposit is almost close to, we have a chart where we compare the LAB values, where we can see the deposit color is very, very close to X chrome. The speed is also almost close to twice that of speed is relatively like maybe about 25-30% more than the other 3000, 7000 systems. It's about 0.2, 0.4 in 4 to 5 minutes. Current density range is more or less similar, 3 to 5 amps per dm square. And one advantage is that this is free from ammonium salts and ammonical nitrogen. So the system also gives an uniform deposition color, thickness distribution, and throwing power. So comparing the color values, hexavalent, we see the L values between 83 to 85, where you can see ultra chrome is very close. It's almost 82 to 84. However, the EcoStar 3000 series is close, but not really very close to the ultra chrome and hexavalent chrome system. But the advantage with the chloride based system with 7000 series is you can also have multiple color variations from X chrome finish to dark chrome finish. Comparing the plating speeds, X chrome is about 6 minutes for about 0.3 microns per thickness, which is the standard average. You can see ultra chrome is will take about 4 to 5 minutes, relatively close to hex chrome. However, the chloride based systems are much faster, like it's almost more than 30%, is close to twice the speed of hexavalent as well as the sulfate based systems. This also gives the flexibility of having multiple colors. The recent development in the trivalent chromium is the sapphire system. This is this can be used for rack, but however, this is specially designed for barrel applications because we all know hexavalent systems do not allow us to plate in barrel because of very high current density requirement and lower efficiencies. So this process is designed specially for barrel applications where we need to plate very small components. So plating speed is relatively okay. It's about 0.2 to 0.3 microns in about an hour's time at a current density of 1 to 2.5 amp per dm square. So it saves a lot of time and cost for racking in general when we want to do it in hexavalent chromium system or other systems when the parts are relatively smaller. The color is also very close to hexavalent chromium. So last but not the least is EcoChrome H. This is one of the revolutionary products which we will be starting at production scale this year, very soon. We have few tier 1, tier 2s who are very interested in starting the hexchrome free processes in India. So this has the ability to plate up to about 150 microns, and the plating speed is also relatively equal to the conventional chromium system. But for getting very good corrosion resistance, there is a need for nickel undercoat if the requirement of salt spray is corrosion resistance and salt spray is more. But another advantage, however, is that this being very bright and soft, bright and smooth deposit with RA values of close to 0.2, the mechanical polishing, which is normally mandatory for hexavalent system, can be avoided with this. So this is an additional advantage. And this is, even though this is a sulfate based system, this can be operated using graphite anodes, which is again a big advantage for the platers. Process is relatively very stable. Waste treatment, of course, is pretty simple due to no hexavalent chromium system, chromium in the system. Makeup and maintenance are both liquid additives, so easy to operate. So to start with, with our European counterparts, they have started with automotive aeronautics, military, and printing cylinders. In India, we are looking at the printing cylinders and automotive as the initial stage startups. Hopefully, we find more applications in the industry, and slowly, we maybe in the coming years, we will slowly move towards the eco-friendly trivalent chromium, hard chromium processes. So to summarize what Ronak can provide, the advantage working with Ronak would be that we have all the types of systems, both chloride and sulfate based, to get the similar finish to hexavalent as well as different colors. And the biggest advantage would be we take ownership of the entire system. So we do provide, in case of sulfate system, we do provide the MMO system, we do provide ion exchange system and all the equipment related to the trivalent chromium. A customer is interested in working with our trivalent chrome system, will get entire package. So there is no excuse like, okay, this anode was bad, this tank was bad and all those things. So we provide everything under one basket. So we take the full ownership of the system from start to end. So which we have already discussed about the ion exchange resins and filtration systems, which can be provided by us. So content wise, that's it from my side. So any questions, I'd be happy to answer.
Thank you, Mr. Kali Praveen, for this very interesting talk about trivalent bright chrome and hard chrome. Thank you. Our next speaker is Mr. Aman von Grauer and Weil India Limited. He has done his Bachelor of Engineering in Chemical Engineering and has more than 7 years of experience in the surface finishing industry. And he is talking about hard chrome plating for trivalent electroless nickel now in a reality version of that. Thank you very much.
Hello. So thank you for today. So first, I would like to thank the ISF management team for giving Growell this excellent opportunity to share our practical insights on trivalent hard chrome. So, my topic is hard chrome plating through trivalent electrolytes. So as I am starting, I would like to say first, from decades, hexavalent chrome is dominated the hard chrome market. But today, if we say honestly, the question is, should we move from hard chrome to trivalent chrome? But it is not. The real question is, are we technically ready? Are we technically ready to move from hard chrome to trivalent chrome? So today I will share my insights on how we can do hard chrome plating through trivalent. Can you change it? So today we will cover the traditional process using hexavalent chromes, what are the pros and cons of it, and alternative options of hexavalent chrome. And now we will say what are the challenges associated with trivalent chrome and what we have done, the key achievements, and what we need to improve in our process. And last, we will summarize and conclude what we will get from the slides. So with the basic introduction of chrome, the chrome has a symbol of Cr and atomic number of 24, an atomic weight of 52 grams per mole. And why we do chrome plating? It is most importantly needed for good hardness and good wear resistance, near about 1000. And this property has been achieved through hexavalent chrome from current market scenario. So we will start with the traditional process, that is hexavalent chrome. And it is the process that is very well known from since 1923. And it gives a bluish finish and hardness of near about 1000 HV. Along with it, it gives a very good taper wear index, less than 10 when we are doing heat treatment of it. And it has very good corrosion. And if we say about the crack pattern, it will have other micro cracks on it. So you can also see the appearance, it is purely blue in color. So if we look after why we need trivalent chrome, there are certain limitations with a hexavalent chrome. The most important limitation is his hazard nature, as we are as we have to give ROHS compliance as well as REACH compliance. We have to restrict the use of hexavalent chrome as low as possible, as well as it is environment pollutant, and we can directly see it is in the water danger class of 3. So what are the possible options for the replacement of hexavalent chrome? The first possible option to give the same wear resistance and hardness, it's electroless nickel. And then we have to give electroless nickel composite coating, then electro-deposited nanocrystalline alloy coating. And what we can do, a thermal spray. And we can also give alloy coating of with nickel tungsten, manganese tungsten, and last, what we will cover today is chromium plating through trivalent electrolytes. So now we will see what are the challenges and how we can tackle them to achieve plating through trivalent electrolytes. The most important challenges is if you can see this structure, it is combined with water molecule and it is a very strong bond. If we do not incorporate any complexing agent, it will not break, and no plating is possible through this compound. So we have to incorporate some carboxylic acids to make a ligand bond so that we can do plating on it. And if we see, if we compare it with hexavalent chrome, the bath conductivity is comparatively very low. And if we complexes, trivalent chrome exists as a ligand complex species. Since it have complexing agents, so it is not only chrome plating, it also includes some carbons when we carbon molecule when we are incorporating chrome. So how we can tackle them? We have to optimize electrolyte formulation and operating window. And for this, since our previous colleague has also already pointed this out, that we have to use a specific type of anodes, mixed metal oxide, because if we use other anodes, there is a possibility to generate chrome 6 in the bath, and which will act as an impurity into it. And we have to incorporate some conductive salts which will improve current efficiency as well as flowing power. And since the tolerance limit of trivalent chrome is less, so we have to introduce the concept of ion exchange, where we can remove the metallic impurities from it. And since the chrome layer, the trivalent chrome layer has macro crack, so we have to introduce strike nickel so that the strike nickel will publish good adhesion and crack control. And we can use the pulse rectifier to improve the total morphology as well as to reduce the stress incorporated through plating. So our portfolio consists of 3 types of trivalent chrome. First 2 are related to decorative part. If we can see trivalent white chrome, it has bright and mirror-like chrome appearance, used for automotive and bathroom fitting. And we also have trivalent black chrome, in which we can give a jet black charcoal-like finish, used for aesthetic and functional applications, and can be plated on brass and steel parts. Recently, we have developed the trivalent hard chrome, and it is on right now, it is on the last stage that we can get the functional coating, the requirement of functional coating for wear as well as abrasion, and used for engineering components. So what are the key advantages that we can get while doing trivalent chrome plating? The most key advantage is we can eliminate the use of most dangerous hexavalent chromium 6, and we can simplify waste treatments. No toxic fumes will be there for the workers who will use this, and we can use insoluble anodes, and no special startup or shutdown procedure is required. So if we see the deposit, the morphology of it, if we can have chromium deposit from conventional hex chrome process, it is looking like this. And if we compare it with propriety that contains catalyst, it will form like this. With the incorporation of catalyst, it will improve. And right now, this is the layer that we have incorporated with trivalent hard chrome and a small strike nickel. It will form like this. This is a SM image of it, and you can see the morphology is looking like this. these are the parts which we have plated with decorative bright chrome, and these are the white chrome parts, and the name which we have for decorative white chrome that contains sulfate and chloride both, tri plus chrome, and these are the parts. So if we compare a comparative overview with the hexavalent chrome, trichrome 300 and durovite TC300. So it is conductivity salts are there, and if we compare it, if we compare with tri plus chrome, it contains chloride and sulfate both. But if we compare with hard chrome, it is only sulfate based. And the complexing agent which we are using in tri plus chrome, it is ammonia and carboxylic acids. But in hard chrome, it is carboxylic acid. But the most important, it is pH. We will cover in upcoming slides, and that with our hard chrome process, it can be operatable at pH 2 to 2.2 and a temperature of 30 to 35 degrees Celsius. It is very less if we compare it with hexavalent chrome. As well as if we see the plating speed, it is for hexavalent chrome, it is 0.3 to 0.4 micron in 3 minutes. And for tri plus chrome, it is 0.3 to 0.6. And if we compare it with our recent process, it is 8 to 10 microns in 10 minutes. But as I already mentioned, it is not only typical chrome plating, it also incorporates carbon, it also incorporates oxygen and sulfur. It is not only pure chrome plating. So this is the Hulsel study for trivalent comparison of hexavalent chrome and tri plus chrome, in which we have given different current densities and checked the thickness, how the covering power is there and how the appearance is. So there is a study of chrome 6 at 8 amps at 5 minutes and tri plus chrome at 5 amps 5 minutes. This is the thickness at which current density. So we have also done with decorative parts the plating on, so to check how the thickness variation is with our decorative chrome. So it has been done with nickel underlayer, that nickel has 10.1 and 0.35 of chrome. So if we see on all the 4 points, the chrome thickness is almost similar. So there is a good conductivity with our decorative trivalent chrome. So this is the data to check whether how analysis is happening with our potentiostat test. So if we compare it with this point, the rate mile per year, lesser will be the rate, more will be the corrosion. If we see nickel with trichrome, the rate is 9.937 into 10 to the power minus 1. And if we compare it with milliporous nickel, it has improved little bit if we compare it with 9.9 to 2.8. So if we want to get more corrosion resistance, we have to incorporate milliporous nickel, which will help to increase the corrosion resistance and which will help to get the properties that we require. But if we compare it with hexavalent chrome, it is little bit high with hexavalent chrome, but it can improve. So we have also performed the cast test with multi-layer of nickel and chrome plated parts. So with triplex nickel and hex chrome, we are able to get 120 hours of cast test. And when we are doing with triplex nickel and trichrome, we are able to get only 48 hours. So we have tried to increase the layer with semi-bright, bright and milliporous. As I already mentioned, when we are doing milliporous nickel, the corrosion resistance is increasing. And we have also tried, because there is a formation of micro cracks. So we are able, we have tried with chemical seal so that it will help to increase the resistance. It is helping when we are incorporating chemical seal or electro seal, the corrosion resistance is increasing with it. So these are the parts from trivalent black chrome. As I already mentioned, it contains both sulfate and chloride, and it can offer the excellent color of Z black when we are doing trivalent chrome plating. So these are the attributes: black chrome with hex chrome and trichrome with TC301 bath. So if we see the appearance, it is matte and it is glass-like appearance. And we say micro cracks are observed, crystalline in nature when we compare it with hex chrome. And if we compare it with tri plus chrome, it is looking like this. And I already mentioned, when we are doing tri plus plating, trivalent plating, it is not only chrome. lot of other metals will incorporate with it. So these are the color values that we able to get with the trivalent hard chrome that we have. If we compare it with Durobrite, Tri Plus, Black Chrome and Tri Plus this. So when we are saying what can be the challenges with trivalent chrome, that is a safer alternative to hex chrome. So I already mentioned the ligand will attach to it, and there is a chance that hydroxo bridge aqua polymer will be formed. We will cover this in upcoming slide, how we can tackle this problem. And there is a chance when we are on introducing high only sulfate bath. So that if the sulfate concentration is increasing by 300, there is a chance that at high current density, there will be a skip plating, blackness observed, as well as burning is also there. So this is the expected phenomena that we are getting. This is the basic chromium sulfate that will react with ligand, that the carboxylic acids, and it will form, ligand will come into at this point, and it will, in this third step, it will reduce to chrome 0. So this is the reaction I am talking about. So there can be a possibility of two reactions that will happen when we are doing trivalent hard chrome plating. The first reaction is hydroxo bridge aqua complex that can form, in which two metal ions will link with OH bond. And there is also a possible reaction that it will also form with oxygen only. So this will, if we want to tackle this situation, we have to optimize the parameter, we have to maintain the pH and temperature and all the complexing agent concentration. Otherwise, this reaction will form and this will not break, which will make trivalent chrome plating very difficult. So if in our bath, we are introducing chromium complex with multiple complexing agents. We have 4 different complexing agents to avoid this problem of hydroxo polymer, and we are using MMO anodes for it. So these are our bath composition, in which we are using chromium metal of 45 to 50 grams per liter. Complexing agents, I already mentioned, we are using 4 types of complexing agents. We are using conductive ions, and for buffering agent, we are using boric acid, and we are also adding some wetting agent to avoid any pits. And if I see about anodes, it is MNO anodes, and depending upon the part, we are giving the current density 10 to 30. As I already mentioned, the USP of this process, it can be operatable at 30 to 40 degrees Celsius at a pH of 2 to 2.2, and it can give 0.8 to 1.2 micron per minute at 20 ASD. So this is the pre-treatment that we follow for this trivalent hard chrome plating. We first use soak cleaning, then we are going to acid pickling, and we are doing to anodic cleaning to smut, as well as cathodic etching to get proper adhesion. And we are doing our chrome nickel as well as nickel activation to activate the surface, and then afterwards we are doing trivalent hard chrome plating. So these are the parts which has been plated at 25 to 30 microns thickness, as well as these are the XRD report in which we can find how much weight percentage is there with the different metals. So these are the XRD report. If you see these two lines, this is hexavalent chrome, this is trivalent chrome. The peak is little bit different. But if we do a heat treatment at 300 degrees Celsius, the peak is higher. The high peak means more structure will be crystalline. So if we compare it with hexavalent chrome, there is a chance that we can get near about 1500 HV of hardness with trivalent chrome because of high peak. Because at high treatment, the carbon will react and it will form a crystalline structure. So this is the hex chrome as plated, and if we're doing a heat treatment, it will look like this. And if we do as trichrome plated, it will look like this. So these are the cross-sectional images of it, and we have done it, how you can see the cracks formation, how the crack formation is there with hexavalent chrome, and if we compare it with trivalent chrome, how it will look. So this is the trivalent chrome inverted microscopic images at 200 magnification, that is nickel with hex chrome and nickel with trichrome, how it will look. So if we compare it with hexavalent chrome and Durobrite TCHR, as I already mentioned, when we are getting as plated samples If we compare it with hexavalent chrome, it is coming near about 1100. But if we compare it with S-plated samples, it is 1024. But in hexavalent chrome, there is no chance to increase the hardness by doing heat treatment. But this is the chance that we can get from trivalent. When we are doing heat treatment, the hardness is going on. So if I already mentioned at 300 degrees Celsius, it goes up to 1700. So hardness is going up when we are doing heat treatment of it, and heat treatment can give the maximum hardness that we can get from trivalent chrome plating. So this is the wear essence test that we have performed. So if we compare it with hexavalent chrome, the Tabor wear index is 2.71, but when we are doing it with trivalent chrome, it is 3.08 at a thickness of 60 microns. We have also performed a test called in which we have put a 66 Newton of force to check whether there is hydrogen trapped on it. And we have done this test for 200 hours. If there is a hydrogen entrapment is there, it will form a blister and we can see the crack on the surface. So it is passing the test, and we can say there is no hydrogen trapment when we are doing plating on trivalent hard chrome. To summarize this, I can directly say hexavalent chromium plating is robust. So we will take some time to establish that process that can compare with hexavalent chrome, but we are on the right track to formulate the trivalent chromium electrolytes, which can give good corrosion resistance, good hardness. Along with it, we can get the thickness what we require. As I already mentioned, with trivalent chromiums, there are lower corrosion resistances there. So we need the use of strike nickel, which will help to increase the corrosion resistance. And by incorporating complexing agent alongside with the strike nickel, we can get the performance that we require. And as I mentioned, we have in our portfolio that white and black decorative finishes, which is successfully commercialized. It is running currently in market. You can use it an innovative trivalent chromium process utilizing 4 ligands. There are some parts plated in this trivalent hard chrome that is there in our stall. If you want to see, you can come at our stall to see how the appearance of trivalent hard chrome is. So at last, I would like to say thank you. If I am ready for any questions, if there are. Thank you.
Thank you, Mr. Aman, for this very enlightening talk about the new things in chrome plating. It was very interesting. Thank you.
Thank you so much. Sure.
As well. So please. It's just Our next speaker is Mr. Sandeep Dua. He holds a bachelor degree in chemical engineering and a PGDM in marketing, and brings over 20 years of progressive experience in the surface finishing. And he is especially an expert in anti-corrosion coating technologies for automotive applications. And he's working at McDermott and Tone India Private Limited. Welcome to the stage. He is talking. He will show us how the future of sustainable anti-corrosion coating is done by how the technology meets the sustainability.
Hello. So good afternoon, everybody. Yeah.
So thank you very much for this opportunity today to MFAI to invite for this session on future of sustainable anti-corrosion coatings. So in the previous presentation from McDermott Anthon, we talked about savings in terms of energy and water. I think we have saved a lot of money already, so I'll not add much. Yeah, so I'll try to increase some more savings for you guys. Yeah. So every successful metal plating starts with a well-prepared surface. We call it surface conditioning. So these are four requirements, when we talk about a pre-treatment in any kind of surface finishing. So temperature, of course, is a major role, and then the chemistry, which is the backbone of that process, time, and of course, the mechanics. So pre-treatment, we cannot say like it's for the anti-corrosion coating or for the decorative. It's for everything, and it's the base of that particular metallic coatings. In India, the requirements are raising every day as per the OEMs, and they need or look for, always a better control of that process. So we have like a controls on the electroplating and the passivations and also on the sealers in a way, except the pre-treatment, which is always lagging behind most of the cases. So it's like a first in the industry as far as India is concerned. So the development is like a cleaner which can be automatically controlled, and also the automatic dosing, and top of it at a low temperature, which orthodoxly will not be possible, which normally operates around 60 to 80 degrees Celsius. Yeah. So here is a typical example of a zinc nickel finish, and we call it like 30%, 35% of the energy is consumed by the electrical heaters, and majority again for the cleaners, be it the soak cleaner and the anodic stations. So what is the need of the industry? So we need a process like which can save up to 50%, which is no more a wish list. So we have a proven results, and then a system which can be automatically controlled along with the SCADA on the lines, like in the degreasing, on the electro cleaners and the ultrasonic stages. So here are the key benefits which we talk about much more in detail, just to give you some glimpses of it. It's a modular system, liquid products, so no more the handling stuff, mixing on the lines and the powder stuff, and then keep it. And then high alkaline design for steel as of now. R&D is working on for the other substrate also. Phosphate and silicate free of strong complexing agent, low operating temperature, of course, yeah, and reduced CO2 footprint, which is under more of more of the people now have this in their KRAs to reduce the CO2 footprint in the industry. So technical advantages: wide temperature range, cleaning efficiency at a low temperature, surfactant systems for all the cleaners, suitable for both rack and barrel processes, and automatic controls. Yeah. Economical advantages, of course, if you are running a system which is not at 80 degrees but on the 40 plus degrees, high yield, reduced rejects, and easy wastewater treatment. So not a special treatment is required for the wastewater. So here we can use in both ways with this new system, soak cleaner and the electro cleaner. We have one component which is suitable for both. And then we need two different additives, which were for soak and the another one is for the anodic cleaner. So again, it's not just the chemical processes. It need a whole system, a synergy between the chemistry, laboratory, equipment, wastewater, and of course, a globally available product supply chain. So how it works. So it's a cleaner, dosing, equipment, automate, and a manual process for soak and electrolytes cleaners. Not a rocket science. If we are using a typical system for zinc, nickel, electrolytic dosing, and the zinc, but in cleaner, it's a first. Yeah. So we need typically two dosing tanks with the alkaline one and the other one with the additive, which can be controlled by the conductivity. So you don't need to check periodical for the analytics. Yeah, much easier to control the system. The unit is customized to control the conductivity of the cleaners and those multiple additives in soak and electrolytes, separately. So the whole system is, supported by McDermott Anthon. So it's like kind of a business to business case. So we can provide this equipment along with our chemistry. So it's not for the sale, but it's only to support the chemistry at the customer end. So energy savings by working at low temperature, precision and accuracy, which was missing and which is still missing in orthodox systems. So it will have an added advantage into that. The system adjusts in real time based on sensor inputs, avoiding human errors and ensuring that the dosages are consistently accurate. Yeah. Cost savings, of course. We have real-time examples of it, and we have a data behind it. We have a case studies, and we know how to operate in a barrel process or a rack process. So we can discuss about it, and we are also customized. Yeah. So enhanced safety, of course, you don't need to, mixing it on the line and handling the stuff in a powder form. Moving from pre-treatment to zinc nickel. And why zinc nickel is again the question. To protect the base or a substrate, we have zinc iron or tin zinc, whatever. But why zinc nickel? So here are some key advantages while going with the zinc nickel. Of course, higher corrosion protection, least hydrogen embrittlement, and it doesn't mean no chance of hydrogen de-embrittlement. So there is no written document, sorry for that, but it's a kind of an understanding between the OEMs and the tier ones if they require for a special hydrogen de-embrittlement or not. But at the very, very last studies are available where it is already proven that it's a porous structure. Yeah. Case hardened steel initiation, heater resistance, wear resistance, uniform coating distribution, cleanliness requirements. Why the cleanliness requirement is and why it is important here is because it is always compared with zinc flakes also. That those coatings are also giving you a higher corrosion protection. But there are certain cases, where this cleanliness requirement from the OEM, especially for the EVs and the electronics, yeah. So where it outscored that product. So I will show you some pictures also for that. So no thread, drive refill, friction control, low contact corrosion. So we have a specialized sealant for that to give you frictional values as per the OEM requirements. So one zinc nickel layer providing key performance characteristics, dedicated post-treatment, adjusting further performance criteria. So further performance criteria means if you need higher corrosion resistant as far as higher, to the base corrosion, to the white corrosion, we can take it up to 3,000 hours also, the base corrosion. Depends, yeah. So here are all the application which can be used with zinc nickel. So we're talking about for this evolution of zinc nickel for the last 5 years or so in India. Europe is already, or Americas are already very, very accustomed with zinc nickel coatings. We have just started. When I say just started, we are not even 10% of zinc nickel as compared to the overall zinc coatings that are available in India. But yes, the times are encouraging, and a lot of queries and a lot of RFQs are already there, and which shows the trend that this year is the zinc nickel year. So let's see, and we're very hopeful for that. To support this fact, like the new developments for the fasteners, because of this EV emergence, the resistant sport welding, which is, going towards adhesives, yeah, 2030 and beyond. So adhesive will grow mainly at the cost of the resistant spot welding, and bolts will go down. These are the projections, right? And the uses of rivets and the smaller fastener will increase. So this is the market trend which we can see as of now. One more advantage why I mentioned the cleanliness. Here is an example of abrasion damage of zinc flake coating. Yeah. So abrasion damage from material handling with vibratory feeders. And we have sorting machines also these days at all the major fastener manufacturers. So which is not very friendly with these kind of coatings. So moving on to sustainability part of it, which is the topic. From the electrical heaters to the rectifiers now. We all know when we talk about zinc nickel coatings, efficiency is always a bit of a question mark. Yeah. Big challenge with the alkaline zinc nickel coatings, electrolyte as such, which will further, increase the cost as far more energy is concerned. And at the same time, a lot of breakdown products, and you need a lot of additions into that, which again, higher your operating cost. So here is a solution. Yeah, it's a conventional setup for a zinc nickel solution where you have an orthodox steel anode or a nickel plated or a actual nickel plated anodes, and you start with and you start with near about 70% of the efficiency of the solution, which goes down to beyond 50s, yeah, with the bath age within a year. And then this is a patent technology, which we call it a membrane system from McDermott Anthon. We can talk about more on our booth because there is a restriction. We cannot place the names here or the product names or technology as such. So how it works? Normally the orthodox ones, you have all the reactions on the surface of the anode, right? And then all the breakdown products are going inside the solution. Ultimately, it's the dense solution is having the low current density, and also the efficiency will go down. So with this new generation anode system, there is a same anode under a ceramic system, which only allow the ions to travel. Yeah. So all unwanted side reactions and side effects eliminated. Yeah. So what it means? Consistent maximize productivity, constant high process efficiency, typically greater than 60% energy savings. Again, we have a very good backup data of this because we have more than 100 installations in the world already, and 3 lined up this year in India. So we have sufficient data to back up this, and these numbers are actual numbers which can say more than 50% of the saving. Yeah. So reduce CO2 footprint, additional reduced cooling required because of low reactions. The chiller will also have low energy consumption. So minimize waste, no evaporators needed, less freezing, less solid waste formed. Yeah, zero cyanide, very important. So very significant energy savings, waste reduction, and productivity increase. The highest level of sustainability and process economy in zinc nickel. So that's it, my side. Thank you very much. So any questions you can ask here, and you are most welcome to our booth at B106. We are happy to answer all your queries on that. Thank you very much.
Thank you, Mr. Sadeep Dua, for this nice talk about sustainability, and it was very interesting. Thank you.
Thank you very much.
Our next speaker is Mr. Akaidosh Patek. He is Managing Director and Global Key Account Manager for Keysoft, and especially responsible for the Asian market. He's a chemical engineer with more than 25 years of experience in the chemical and technology sector. And he will talk about a new generation of decorative nickel plating for sanitary fitting industry. Welcome to the stage.
Good afternoon, ladies and gentlemen. Thank you very much for invitation for Metal Finisher Association of India, and thank you for our partner company Future Code Technologies. Because company Keysoft is the first time in India, I can start with very short movies, 90 seconds, where present our headquarters in Germany. Thank you. Now we can start with presentation. Today my topic will be new generation decorative nickel plating, especially for the sanitary fittings, but this is not only for the sanitary fitting. Our company is founded 1921 in Berlin. That means we have more than 100-year experience, exactly 105 years in this year. We started from the produce the polishing compounds like the polishing paste, polishing emulsion, buffing wells to polishing and grinding belts. This is top when we start. Of course, the next technology when we started was the pretreatment, was the electroplating, phosphating. But about our portfolio will be the next slide. Because today I will be focusing about the nickel plating. This is some customers from, especially for the sanitary fittings, like this is the world's company, like Grohe, like Hans Grohe, Hansa, Ideal Standard. This is our customers in Europe, China, in Asia, in Thailand. Short about the portfolio, like I said, about the polishing, pretreatment, decorative electroplating, functional electroplating. We have passivation, phosphating, raw materials, anodes. Okay, now we start about the decorative nickel. In this slide is the 3 our technologies can show us the evolution, how we change our nickel plating technology. The first is about the 19th. We start with Orion 3000. It's very good leveling. We started especially for the POP plating. It's medium concentration organic additives. Was very brilliant finished surface. The next technology was started about 25 years, 20 years ago, was Orion 4000. It's really the best leveling performance and brightness. I show a little bit less how is the working this technology. And it's very perfectly for the zinc and brass materials, but not only, for steel too. And today I will be focusing in Orion 5000, where is the very good leveling, is minimum required of the organics additives, and is improved nickel layer noble. Here it is this from the scanning microscope. The show us is the nickel layer on the raw material. Sorry, now here. But this is the nickel layer. When we see is the pillar structure, but this is the only basic nickel bath. Like is the nickel sulfate, chloride sulfate, and boric acid. We add only for the weighting agent, not more. This is not brightener, not leveling. This is not organics additives. For all tests, we have the same condition, like the 5 ampere per square decimeter. pH is between 4 to 4.3. Temperature is 55, 57 Celsius degree, and this time is 18 minutes. When we add the organics additives, is nickel additive, TRA, and Orion 5000 is only 0.2 milliliter per liter. We see the structure is changed, is laminar, and the most important information for is the Orion 5000 started the plating on the low current density, not from all. I show you for the here. Sorry. Normally, after the 6 minutes in Orion 5000, this is the start for the low current density, only for low current density. The next is the high current density. So it's very important because we can reduce of the nickel layer thickness. For example, about the 20-25%. I only check back one slide. This is similar, but this a little bit more concentration, the Orion 5000, 0.5 milliliter. This is the optimal dosing for this technology. Why is the important the mechanism nickel plating was the start for the LCD because we can reduce the nickel thickness and we have the same appearance. We have very good quality, the nickel layer. I talk about this because normally in the total cost nickel technology, the organics additives is about 5 to 8 total cost the nickel technology. But the metals, the nickel anodes, it's about 50 to 65% total cost the nickel plating. So when we reduce the thickness nickel about 4 or 5 microns, we reduce the usage of the nickel anodes. So this will be very big benefit for the customer. This is the calculation when we adapt for each customers when we can start cooperate about the nickel plating. We see this is the calculation for 18 microns. The surface area is 1000 square decimeter. We need how many ampere hour we need, how many nickel we need is the information. This is the information about the price, what is the cost for the additives, and this is the cost about the nickel. Okay, the price is the euro, but we can adapt to the each value. If we have, because it's the after the calculation, for example, 24, like the 5-6 microns more, the cost of the nickel is more than 50 euro for the surface 1000 square decimeter. So this is about 15 or 14 euro less. That means it's about 35% less cost when we plating in Orion 4000. 5000, sorry. Very short characteristic, our technology is Orion 5000. It's very good leveling. It's really very extraordinary ductility, what is the very important, especially for the sanitary fittings, because when we started many years, the sanitary fittings was very simple and round shapes, like for example, like this. But now the designer is total change the sanitary fittings, and we have like the very sharp edge. We have like the 90-degree angles. So now design is total change. So we need very new modern technology, and this is the reason when we create is the special technology like Orion 5000. Of course, it's very good corrosion protection too. When we talk about the operating condition, generally is the standard, like is the nickel is about 75 gram per liters, the chloride is 18-20 gram per liter, boric acid 40 gram per liter. It's like the standard. About our organic nickel additive and nickel additive terra is the concentration 15.3, pH between 4 to 4.5, temperature optimal 55 degree. The optimal current density is 5 ampere per square decimeter. Plating speed 1 micron per minute, but of course, when we have the current density 5 ampere per square decimeter. About the organics additives, we have 4 very important organics additives. Nickel additive 520 is primary brightener, responsibility for the throwing power and ductility. Nickel additive TRA is the support for the brightener. Orion 5000 bright is mixing a lot of the organics additives, responsibility for leveling and brilliance. And Orion 5000 LCD is especially responsibility for the dispersion of the electrolyte. Orion 5000 MU, we use it only when you're preparing the new makeup, when you're preparing the new bath. We have some different weighting agent. This is depend what is the air agitation or bar agitation. So we can start for this. If you have more question, please invite us in our partner stand. FCT is the B151, 156. I can explain a little bit more if you really interesting. So thank you for your attention.
Thank you, Mr. Petak, for this interesting talk about the surface treatment we all share.
Thank you.
Hello. Thank you, Mr. Florian, for chairing this particular session. And we would like to give you a token of appreciation from MFAI.
It's a pleasure. It's really a pleasure. It was a pleasure. Hi.
वो side में बैठ।
Ajab. So, thank you.
ये
That's my little.
our next speaker is Mr. Vilas Paliwal. I welcome him. Oh, he is going to chair it, na? Hello. Our next chairperson is Mr. Vilas Paliwal. He's a technical director in Grow Metachem, Pune. He has got 46 years of experience in the field of metal finishing, in technical services, sales, marketing. I welcome Mr. Vilas Paliwal.
It's okay.
Now in action, no? No, but thời điểm có một vài chuyến xì lật thôi anh nắm
Subject है अरे हाँ हमारे में ठीक है
Good afternoon. Now we welcome Mr. Srilal Karuna Rathane from Groveronville and Mr. Kozhauki Sugano.
ओके लाई है
Okay. Yeah. Very good afternoon, everyone. I'm Srilal from MFAI Metal Coatings. First of all, I would like to express my gratitude to the chairman and organizing committee of ISF giving this opportunity to us share our PFAS-free technology insights. Today, you know, one of the hot topic in the industry is PFAS regulations. So before I come to this topic, I would like to share the insights of our company MF Metal Coating Group and also our products as a anti-corrosion solution provider and impact of PFAS and PFAS on our top coats and PFAS free technology development insights done by our company and also our strategy for this regulation. Okay. So NOF metal coating is the world pioneer of zinc flake technology. So we deliver high performance, water-based and eco-friendly anti-corrosion solutions, highly trusted by uh, leading automotive and non-automotive OEMs. As of today, we are in this industry for last 53 years, and I am happy to say we are holding nearly 50% of market shares worldwide. So this company is completely owned by the Japanese firm called NOF Corporation, and this you can see our this is as a global company. So we are in, our presence is in Asia, Japan, Korea, China, and Europe, and North and South America. So we have divided the market into three regions. One is Asia is controlled by the NOF Metal Coating Japan, so our headquarters in Kawasaki, and NOF Metal Coatings Europe for the Europe, and also for US NOF Metal Coatings America. So one of the biggest strength in our organization is having a global R&D. So as you can see, so we have our R&D in multiple locations, including Korea, Japan, Europe, and North and South America. So having this global R&D, we were able to provide local requirements as per each and every OEM's requirement. We were able to deliver in local. Also, you can see here another strength in our organization is we have our manufacturing locations in multiple regions, including Japan, Korea, Europe, and North and South America. So network in India. So in last 3 decades, we are in India. So our partner and also the distributor, Grow and Well. So we have association with them in last 30 years. And this is Geomet. Our technology is a license-based business. So we have more than 30 licenses from top to the bottom across the country. Okay. So our technology, so as an anti-corrosion solution provider, so we are mainly focused of the two types of corrosions. as you know, there is one type is atmospheric corrosion and another one is bimetallic corrosion, we say galvanic corrosion. So when the steel exposed into the environment, it create or it formed its oxide layer, we say that's red rust. And the next galvanic corrosion, when dissimilar material contact with each other, because of this galvanic action, the lower noble, weaker material always start corrosion. We say this is galvanic corrosion. So our product primarily protect both this atmospheric and also the bimetallic corrosion. So our technology, so our key product is the Geomet. So it is a water base. It can provide high performance, excellent corrosion resistance. The layer is less than 10 microns. The Geomet is a combination of zinc and aluminum flakes and the inorganic binders. So if you talk about the mechanism of the zinc flake coatings, so there is 4 functions in our product. One is barrier protection, another one is galvanic protection, and we say passivation and also self-healing. So today I do not going to talk deeply about the mechanism of Geomet because of this time limitation. So because of this mechanism, so our product, the Geomet, can provide excellent anti-corrosion. So benchmark with the product is the 2000 hours of SST. There are some industries which require 3000, 4000 like wind energy. So we are able to provide the solution with our this technology. And also this technology has high scratch resistance and heat resistance. And also there is no hydrogen embrittlement comes from the process because we do not involve any acid pickling process to do this coating. So this is how we do the process. There is two methods of coating. One is dip spin and also the spray. So dip spin we use for the bulk production. Spray we use for the larger parts like brake disc or pipes. So very easy steps we have to follow. One is pre-treatment, degreasing and shot blasting. After that, coating and curing. This is very simple steps you have to follow to treat our technology with your parts. So now I get into the impact of this PFAS. So PFAS we know like it's a synthetic chemical, and also we know it's a forever chemicals. Why we say this forever chemicals? Because of this strong bond of carbon and fluorine. It is not easy to break. So this can persist in water, soil, or even in the human blood. Because of that, today they have found out there's a risk for the human and environment. That is why this PFAS regulation is getting stricter. In case of humans, so it can be a cause of cancer, liver effects, and immune system effects. So that is why now the world is going to ban this PFAS product, which is in each and every industry. And also in the industry point of view, so there is a huge challenge to find the alternatives of PFAS. Even we find some alternatives, it is not cost viable, same as PFAS compounds. So these are the products and the industries can be impacted by the PFAS. We are in this coating and surface finishing, also food packaging, and also textile and medical equipments. All these industries are impacted by this PFAS regulation. So when it comes to the regulations, before 2024, there were many activities happen, especially in Europe. And also they validated this PFAS restriction test in end of 2024. Now it's going to implement. By 2020, so from this year, I think the most of the countries, they will adopt this regulation, and by 2027, 2028, most of the regions, they will enforce to adopt this regulation. When we talk about the region wise, US, Europe and Asia, so Europe, they have already adopted for some water applications. In case of US, they have already adopted some PFAS regulations for the water application. In Europe, especially France and Denmark, they have already announced and banned PFAS, especially for this food packaging. Asia is not into that much, but Japan, Korea, and Taiwan, now they have already started discussing about the regulations, and they will align this PFAS regulations with the global trend. So these are the categories introduced by the ECA. So in our case, in our top coats is in the lubricant category. So before I talk about the PFAS, so I would like to explain the top coats we are using. There is two types of coatings we have. One is the base coat. Over the base coat, we use the top coats. This top coat we use for control the COF coefficient friction, and also adjust the COF coefficient friction, and also our top coats can enhance the corrosion resistance as well. Also, it will minimize the galvanic corrosion. So in here, so lubricants and also color pigments you can see in the top coats. The color pigments we use to identification purposes. So these are some of our product portfolio, so which contain PFAS. These are very popular in the each and every industry, especially in automotives and wind energy, solar. So we have to we have to find the solution to PFAS free, to offer the PFAS free solutions to the industry for these type of top coats. So in PTFE, as I previously mentioned, so we are using lubricant. In the lubricant, PTFE is there. PTFE is one of the category of PFAS. So we have to find the alternatives of PTFE. So this PTFE we use only for the frictional properties. So NOF, we use only lubricant, and PTFE only for the lubrication purposes. So this is the sum of the technology we are developed and also underdeveloped in our organization. This plus VLH, this is very popular in all these Tesla, General Motors, Stellantis, Volkswagen. Especially in this top coat is mainly used in Europe and US automotive OEMs. So they have requested us to add some value with the new top coats. Therefore, so they wanted to check whether these top coats are from NOF metal coating top coats. For that purpose, we have added fluorescent pigments, and also for the aesthetic look, we have introduced aluminium pigments. So as you can see in this image, so the previous top coat which contained plus BLS, you can see that after the coating, some scratch marks are there. Actually, zinc flake coating is not a functional coating. It's a functional coating. It's not a decorative coating. But in reality today, most of the OEMs, they require, they need up to some certain level of the aesthetic look. So therefore, we have to introduce for the new top coats, the aluminium pigments to improve this, the appearance of the coatings. Also, when it comes to the top coats, so we have done various tests against to the various type of surface. So this is about the previous top coat about the plus VLH. So we have done tests with the existing product which is contained with the PFAS, and also the new top coat without PFAS. You can see in the all these graphs. the behavior of PFAS and PFAS free is almost same. And this is another top coat which is being used in the US for the GM, General Motors and Tesla. So this is also we have developed PFAS free, and also we have added fluorence pigment and also aluminium to give a much better appearance for the coatings. This is another coatings XL2 silver. This is also very popular in mostly in the automotive sector. It will give the very lower friction. And we have developed this one also with the blue color fluorescent pigment, and also added some aluminium pigments for to improve the appearance of the coatings. So in when we talk about the in Asia, mainly as a this is as a Japanese company, so we have a very good connection with. We are a major supplier of the almost all Japanese OEM. So as of today, they don't have any request to improve the appearance, but therefore we do not have added any aluminium pigments for the mainly use in the Japan Asia market. And also we have already completed the PFAS from formula. We will come up with the new top coat by end of this year. Yes, the finally. So our conclusion, our group strategy, we will phase out PFAS worldwide and also from all our product portfolio. So we will launch a fully PFAS free generation of our Plus and Geomet series, and we will align production and applicators worldwide to unified PFAS free standards. And by 2030, we will remove all the PFAS compounds from all our products. Yes, that's all from my side. If you want more information, please come and visit us in Grow and Bale stall. We are there, and this front of the entrance. Thank you. Thank you very much.
Hello. Thank you, Mr. Srilal, for your exhaustive information on the Geomat.
Thank you very much.
Now, I would like to invite Ms. Nipu from Autotech India Private Limited. Hello. Now, I would like to invite Ms. Nipu, Autotech India Private Limited. The subject is advanced decorative finishes for metal and plastics.
Hello. Hello, everyone. Am I audible? Yes? No? Thank you. I am Neetu, as it's already written there. I am the responsible for the management of technical center in MKS for India. And I would be today taking you through. Can we have the presentation up, please? Yeah, sure. I would be taking you through the advanced decorative finishes for metals and plastics today. I'll quickly take you through the legislation update. As I've seen in last 3 to 4 talks, it was the topic of discussion, so I wouldn't spend much time there. Followed by, I'll give you a brief on the decorative and POP applications, and followed by our patented Covetron process, which is chrome-free and non-PFAS etch for POP. Followed by that, I would be spending some time on trichrome finishes, the family of finishes of bright to dark finishes. And I'll also give you an update on the mist-suppressants that we have, which are non-PFAS, and an outlook in summary to wrap up. Coming to the legislation updates, for hexavalent chrome, we have, for hexavalent chromium, we have, no, it's not working. Now it's audible? No. Mic. It's there. They say it's not audible. Now it's audible? Okay. For in Europe, for each, no. Huh? Okay, I'll hold it in hand. Make it better. It's better now, I guess. Yeah. Beginning 2027, the decision of final option would be expected. And 2028, there is a restriction expected coming into force. Coming to the PFAS, the deadlines are being extended. While the potential deadline was in 2025, there are delays already. And for the rest of the world, it is different timelines of up and down of 1 year of 2025. Okay, we cannot use hexavalent chrome. We cannot use PFAS containing wetting agents. What do we have in alternatives? And what are the recommendations from our side? For hard chrome, we have blue chrome process already running successfully at 40 plus customers worldwide. And we have fumal lock, which is the mist suppressant for hexavalent chromium bath. And in decorative plating, we have trichrome finishes, and we also have trichrome etching solution as well. And we also have wetting agent 100, which is PFAS-free solution. Coming to POP, we have the chrome-free etching solution, Covetron, and we also have WA POP, which is the mist suppressant and pre-dip for the etch. A brief on decorative and plating on plastics. Plastics need to be pre-treated to have a fine conductive layer on the plastics, and we do achieve it with multi-layer of metals, copper, nickel, followed by chrome. Talking on our Covetron 600 process, this is chrome-free, and the key features are this gives similar etching pattern compared to the conventional etching process. Here you can see the SEM images of the parts etched by chrome 6 etching versus the parts etched with Covetron chrome-free process, where you see the structure is very similar on ABS and ABS-PC parts. This fulfills the standards that industry requires, aesthetics, adhesion, thermocycle tests, and compatibility with existing plastics. And also few of the 2K, 3K materials is under production. To quickly take you through what is the process, there are pre-treatment processes, electroless. We start with the Covetron etch, followed by a reducer, activator, accelerator, and an electrolyte nickel layer that gives a fine conductive layer on the plastic. And we give a pre-plate copper dip. And then going forward, the steps would be electrolytic, where we give acid copper, semi-bright nickel, satin or bright nickel based on the requirements, and MPS nickel followed by the trichrome. To give you an understanding of what is the difference with chrome free and the conventional process, we have etching which runs at 35 degrees Celsius, and the dip time would be 5 to 20 minutes depending on the material. the sustainability leaders that we are in the market, we also have the regeneration unit for this Covetron process, the etching process, which reduces the chemistry use and disposal and also extends the life of the solution. The process has also passed all the thermal cycle and thermoshock tests defined by different OEMs. And you can see the finish after the PV 1200 tests in the photo on the right side. And also these are for ABS and ABS PC parts, where we see no changes after PV 1200 tests. Which are the materials that are compatible to our process, where our process can run fine? We have multiple of them. For example, we have ABS, ABS-PC resins, multiple of them are covered, and over 3 lakh samples plated in our Atotech lines globally. And other materials tested are PEEK, Altem, PP, 3D printed, etc. And compatibility with 2K and 3K materials is verified on large references. And the resin, the part geometry, and the injection molding process is all of importance here. Talking of the field experience that we have, as I stated, we already have this process running at multiple customers worldwide. We have this success stories on ABS and ABS PC with multiple OEMs. And we have selectivity confirmed from even on 2K and 3K materials. The appearance, adhesion, thermal cycle test, everything passes and is as per the requirement. And it is in production for exterior and interior parts. For non-automotive customers, validation is under production. Continuing on the field experience, as it might look that the points are similar, but then what I told earlier was our expectations. What I'm showing now is from the field that we have we showcased good ability to plate fine on ABS and ABS PC materials, and not all technologies can offer this. So we are the first in the market. And ability to plate on multiple materials like PEEK, PP, and 3D printed is another one which is achieved already in the market. And industry requirements of adhesion, appearance, and thermocycle tests, everything is passed. And compatibility with 2K and 3K materials is validated on many references. Talking on the family of trichrome finishes that we have bright and dark finishes. Under bright, we have trichrome plus and trichrome ice. Under dark finishes, we have smoke 2, shadow, titan, graphite, and phantom. These are the different range of finishes that we offer in bright and dark finishes. And our processes fulfill the requirements of the automotive industry and are approved by many OEMs. Talking of the bright processes, ice and plus, the CAS achieved is more than 80 hours, and the NSS achieved is more than 480 hours. And color depends on the process and the NSS. You can see the pictures of the NSS test with Triseal 500, which is the post-treatment, and Kestanich test with O10 rating, with Triseal 300, which is our pre-treatment, post-treatment after the trichrome. Talking on the dark finishes of Titan and Phantom, we have achieved more than 80 hours of CAS and more than 480 hours of NSS. And you can see the CAS test of 96 hours with O10 rating pictures and 480 hours of NSS O10 rating pictures here. Talking of the post treatments, we have PFAS-free post treatments available with us already, and these are Triseal 300 and Triseal 500. Both of these are for NSS requirements, and they have not shown major or any significant help on influence onto the CAS absorbed. And the bright color, for the bright colors, you can use Triseal 300, and for the bright and dark colors, Triseal 500 is working fine. And both of them give more than 480 hours with O10 rating. The final chrome layer is always a part of the multi-layer system that we know. And over 200 customers we have worldwide for these trivalent processes. This is the process flow you can quickly go through. We have non-PFAS mist suppressants that I would quickly want to take you through. WAPOP is our etching for pre-etch process, which is PFAS free, and wetting agent 100 is our decorative hexchrome mist suppressant. Supply chain, we really have to look into it. If you are because from OEMs till the customers, equipment suppliers, everybody has to be ready to take up these regulation, the effect of regulations. So please be prepared, as we are already with the products. I would like to close saying that beyond the reach for many, for not for us, we are ready with the sustainable products that are needed for the market. Thank you. For any queries and further informations, please drop in at our booth. Thank you.
Hello. Thank you, Nipu, for your nice presentation.
Thank you, everyone. I hope all of you are having a lovely time. Platforms like these are excellent to share knowledge, and this is how we grow, this is how we build our country. And I am truly honored and privileged to invite the next person here. To be honest, his achievements are immense that I literally had to write it down. So I'm going to read it out. I am truly, absolutely privileged and honored to invite a true pioneer of the Indian PCB surface finishing industry, Mr. Viral M. Bulani. Can we have a huge round of applause? This is Mr. Viral M. Bulani. With over 5 decades of industry leadership, Mr. Bulani serves as the president of Omega Corporation and is a visionary force behind the growth of India's printed circuit ecosystem. As the former member, a founder, former member, president of the Indian Printed Circuit Association, he has played a defining role in shaping the industry's direction and standards. It does not just end there, ladies and gentlemen. A chemical engineer by qualification, his expertise spans turnkey PCB project execution, non destructive testing, and plating thickness measurement with technical papers presented at the Indian Society for Non-Destructive Testing and the Metal Finishers Association of India. His global industrial exposure goes across the USA, Europe, Russia, and Asia. And I can keep going on and on, but let us listen to what this man has to say. I invite Mr. Viral M. Bulani on the stage. A huge round of applause, please. I invite the present members of the MFAI Association to kindly join in felicitating Mr. Bulani. All members of the MFAI, if you are here, kindly join us in felicitating Mr. M. Bulani. Thank you so much for joining us today, sir. What a joy it is to have you at ISF 2026. For one last time, can we have a huge round of applause for the team and Mr. M. Bulani?
Hello. Hello. Good afternoon, everybody. And it's a heartening thing for me to see how Indian Surface Finish Industry Association and MFAI together has been organizing such wonderful exhibition and events to exchange the technology, which years back, I can't exactly remember the number of years, but I know one of the founder, Mr. Kamdar, who is here, who had made me a member, life member of this association. And it's a pleasure for me to, see you all over here. And I wish you a great success and lots of progress. I mean, we as an Indians can do a lot, and we can excel in this industry in future. And world is expecting under the leadership of our Prime Minister, Mr. Modi. So let's make it happen. Thank you very much for this honor, and I appreciate. Hello. PCB of the future and effect of the final surface finishes. The best final surface finish for 5G application by Mr. Rajesh Verma from Chemtech Surface Finishing Private Limited. I'll just give you a brief of Mr. Rajesh Verma. Mr. Rajesh Verma is a managing director, Chemtech Electronics. Rajesh has master's degree in chemical technology and a management degree from IIM Indore, with a career spanning 35 years, primarily in PCB and electronic industry. Majority part of his career has been with Autotech. From 2021 to 2023, he is the business director, India, MKS Autotech. Key responsibility to achieve the growth and targets of electronics and GMF chemical business in Indian subcontinent. 2014 to 2020, he is the business director, Electronics, Autotech India, responsible for Autotech Electronics business in India. 2002 to 2013, business head, Electronics, Autotech India, responsible for Autotech Electronic business in India. 1990 to 2001, several positions handling technical services, sales and marketing, product development, business management for materials, consumables, and equipment for the Indian PCB industry in Max India, Max Autotech, and Autotech India. Mr. Rajesh Verma, please.
Yeah, hello. Good afternoon, everyone. And I'm thankful to all of you who have taken out time from their busy schedule to attend to this presentation. Thank you very much. Basically, my topic is the final finishes, the future of the final finishes on the printed circuit board. We know the PCB make the backbone of the modern assembly. Also, the PCB industry has gone
from several changes, starting from the single layer PCB to double side, multi-layer, HDI, flex board, and flex rigid boards. It's not only the PCB has grown in terms of layer, also there has been the miniaturization of the PCB and also complexity of the PCB. And because of that, the requirement of a final finish for PCB becomes a very, very important criteria. We have several of the final finishes available for PCB like HASL, ENIG, EPIG, OSP, immersion tin, and immersion silver. They all have their advantages and disadvantages. I will just go through these finishes one by one. What is their function? First, HASL has been a finish in the market since a very, very long time. It's a very robust process. It gives all the requirement qualities what are required from PCB, but the planarity of the surface is a question mark, and due to that, for the modern PCBs, it's not a preferred surface anymore. ENIG has been in the market since more than 35 years. It's a fantastic finish. It meets all the requirements, but since it is using the precious metal like gold, this finish becomes very expensive. ENEPIG is electroless nickel, electroless palladium, and immersion gold. This finish, I could say, is a universal finish. It meets most of the requirements. But since it is also using, in addition to gold, it is using palladium, which has a tendency to break down. So this finish becomes little bit difficult to control. EPIG is another form of ENIG, which we can say is a electroless palladium immersion gold without immersion tin. OSP is a fantastic finish. It has been in the market since a long time. It gives a very planar surface, and it's also a low cost process, but multiple soldering is a difficult thing with OSP. Immersion tin is also a very good process. It is very popular in Europe. It is very cost effective process, but at the same time, you can plate only maximum 1 micron of thickness with this finish. Immersion silver process also started more or less at the same time when immersion tin started. But immersion silver has the problem of tarnishing and also etching. So due to that, this process came down. But Technique as a company has been able to solve these problems. And now immersion silver is again becoming very popular, especially for the high frequency application. We have so many processes. Now we have to decide which final finish surface, which final finish to be used for PCBs. So these are different criteria. Of course, cost is a very important factor. You have to decide based on the cost. Then multiple thermal shock is something which is required. A final finish should meet that. Cosmetics is very important because it goes as a product. The final finish goes as a product to the customer. Also, corrosion resistance is very important. Surface should be planar. Like in HISL, we don't have a plan surface, and because of that, we have issues with that process. So planarity is very important. Abrasion resistance is very important. Solderability is required. Then process should be able to do gold wire bonding, aluminum wire bonding, and copper wire bonding. There is no single final finish which can cover all expectations. Who decides which final surface finish will go on the PCB? This is not the PCB manufacturer who has to decide this. It is the OEM which decides which final finish will be there. So it is very important to follow the roadmap of the OEM to find out which final finish will be required in future. Now the final finish requirement related to signal loss. My presentation is mostly for the final finish for the 5G application. So I will focus only in that area, and signal loss becomes a very important factor when we are deciding a final finish for the 5G application. So if final finish should be non-magnetic, should have low acceptance, possible thickness, good conductivity, a smooth surface is required very much, but the smooth surface is not only dependent on the final finish. The dielectric also plays a very important role here. The dielectric thickness, the copper, how it has been put on the dielectric, that gives a smoothness to the surface. The other consideration are it should be solderable, resistant to corrosion, bendable, it should have low contact resistance and ability to withstand the harsh environment. So now which is the best final finish for high frequency? We have seen all the finishes. We have seen what is the positive and the negative with various finishes. Now we have to find out which is the best finish for the high frequency. Obviously, the answer is not that easy. The end user requirements are not clear and keep changing. What they require today, their requirement will change tomorrow. OEM requirements keep changing. So it's not so easy to decide. Acceptable signal loss for one application is not acceptable for another application. Not only the final finish has an impact, but circuit design and construction of circuit also plays a very, very important role. As the gigahertz increases, need for proper design and final finish changes. In this chart, we are comparing the conductivity of the various metals. Obviously, the silver has the best conductivity, followed by copper, gold, and nickel. Palladium is robust, and it is followed by tin and solder. Now, we need to see which final finish is best at 20 gigahertz. So this is a comparison of various final finishes like OSP, immersion silver, immersion tin, ENEPIG, ENIG, and EPIG. We can clearly see that the OSP, immersion silver, and immersion tin are performing much better than ENEPIG and ENIG. Why? Why it is so? Because we have a metallic layer in ENIG and ENEPIG, which restricts the signal flow, and this is the reason OSP, immersion tin, and immersion silver performs better than ENIG and EPIG. When we do the same study at the 40 gigahertz, you can see even the immersion tin is also not a preferred finish. So only preferred finish is OSP and immersion silver. Based on the last slides, silver is the best. Then why we should bother about any other finish? Let's go ahead with silver. But the answer is again not that easy. The end user requirements are not clear and they keep changing. Acceptable signal loss for one is not acceptable for another. Without knowing how the end user plans to use the circuit, we cannot recommend any final finish. The good news is that Technique, we as a company have enormous knowledge about the final surface finish, and we can find out which final finish is the best for which requirement. We have compared his ENIG finish against 3 different criteria, like what from the fabricator point of view, the assembler point of view, and also from the OEM designer point of view. We can clearly see that from the fabricator point of view, ENIG is not a preferred finish because it is expensive, very costly process, and also it is not a user-friendly process. When you set up a ENIG line, there are several process steps in this process. It starts from cleaner, micro etch, pre-dip, activator, electroless nickel, gold. So it's a very long process. Not only that, it's a very sensitive process. It is difficult to control this process. On top of that, the controls are pretty stringent, like we have to have 85 or 90 degrees centigrade temperature to operate this process. So it is not such a user-friendly process. But from the assembler point of view, it gives a long shelf life. You can keep the boards for a long, long time after the finish. So it's become useful for the assembler. And from the OEM designer point of view, you can have touch contacts with this process, and it works in the severe environment like automotive and aerospace. When we make the same comparison for the immersion silver process, we can clearly see that It's a very cost-effective process. The cost of the process is much lower than ENIG, and even in comparison to immersion tin, it is a lower cost process. It's a quite a friendly process. It's a only 3% process. The controls are easy, and you can use this process quite easily. From the assembler point of view, shelf life is okay, wire bonding is okay, touch contact is okay, and from the OEM designer point of view, this process can be used on the flexible boards, which is a very important point, and all the signal losses are pretty low if you are using the immersion silver process. Now, how to choose whether to go for immersion silver or to go for OSP? So here we are comparing the signal loss against various processes, and we can clearly see that with immersion silver, we have the minimum signal loss followed by OSP and the immersion tin. ENIG, EPIG or EPIG is completely out because we have very severe signal losses with the usage of these processes. As far as the cost is concerned, we have the best costing with the OSP process, followed by immersion silver, followed by immersion tin, and obviously all the gold related processes are very, very expensive. So if I have to make a choice, what should I do when I'm deciding on the final finish and I have to take the signal loss into consideration and also the cost into consideration, then obviously my choice will be immersion silver because I'm getting quite low signal losses, and at the same time also I'm having a pretty good costing. Yeah. So it's clear that for as far as the signal loss is concerned, 5G is concerned, immersion silver becomes the perfect choice. In recent years, Technique has come up with two processes for immersion silver. One is ASIG process, which is autocatalytic silver immersion gold process, ISIG process, which is immersion silver immersion gold process. We have the complete knowledge of both the processes. Anybody wants to have further information on these processes, they can come to our booth. We can give them additional information. And these processes are going to rule the market as far as the 5G is concerned and the high frequency boards are concerned. That's all. Thank you.
Hello. Thank you, Mr. Rajesh, for your nice presentation of PCB. Hello. Now our next speaker is Mr. Bharat Shah from Artex Serpent Chemicals Limited. I'll just give it brief in short. Mr. Bharat Shah is MTech, BTech, and then MTech in Chemical Engineering, both from IIT Powai, Mumbai. And his MTech specialization was basically electroplating, and professional experience presently is working as a general manager R&D in Artex Serpent, and specially working on chromium plating, trivalent as well as hexavalent based chrome, and some of the other processes like phosphating, electropolishing, etc., and then plating specialty chemicals and the products at site. Mr. Bharat Shah.
Good afternoon, dear friends and colleagues. Topic for my today's presentation is decorative travel computing. I'm going to give brief overview, outline on the basic chemistries involved in travel and chrome plating, which is increasingly finding more and more industrial use. As far as concerned, I'm going to refrain from using any trade name. I will only touch upon the basic chemistries involved in the travel and chrome plating. Just now I was mentioning it is increasingly finding more and more use. These are the typical industries where currently they have been successfully operated for many, many years. Automobile, furniture, sanitary fittings, and industrial. These are given some typical pictures. And slowly more and more, as reach and ROH is becoming more stringent, more and more industries are coming for adopting travel and chrome plating. See, why the travel and chrome plating? See, for almost a century, hexavalent chrome plating is in force and still being utilized. But its main drawback is it is a suspected carcinogen and very hazardous, not only to the human beings working, but also to the plant and machinery and also effluent treatment plant. So it eliminates the use of chromic acid, and these are the various benefits you get. Apart from eco-friendly nature, there have been some productivity improvements also. It gives better coverage, so you can load more parts per rack. So higher productivity for the same capacity of travel and chrome bath and hexavalent chrome bath, you can more productivity. And there are nothing like white wash, which is a very common thing. Whenever there is current interruption, that white wash problem frequently occurs in hexavalent chrome plating. That will not be there. The main striking difference between the hexavalent chrome and the trivalent chrome, I will just touch upon the basic thing. See, the hexavalent chrome plating bath are operating at very high concentration of chrome, which is about 125 gram per liter, equivalent to 250 gram per liter of chromic acid. As against this, the two trivalent chrome plating chemistry which are in operation now successfully, one is chloride and the other is sulfate, which I am going to discuss later on. It contains chrome metal of only 22 and 14. So you can see the vast difference in the chrome metal used in the basic chemistry in the two processes. So these are advantages. That's why more and more work is being done to develop the practical trivalent chrome chemistry. So in trivalent chrome plating, I will touch upon some gray areas also later on. But then metallic impurities are very much detrimental to the good plating. So I will now give general consideration of what are the precautions and what processes to be taken care of for getting good quality trivalent chrome plating. So rinsing is very important for trivalent chrome plating. That is not so case in chromium plus 6 because of metallic contaminations at high concentration can be tolerated in hexavalent chrome, but not in trivalent chrome plating. So after nickel, you have to have proper rinsing. You can use either counter-current water flow, double dip, or agitation, or any combination of these. Idea is traces of nickel solution which is adhering to jobs or racks should not go into the trivalent chrome plating bath. So for thickness also, when you come down to general thicknesses, characteristically, it changes the crystalline structure changes from microporous structure to microcrystal. So it is being observed that less than 0.15 microns of chrome, trivalent chrome, it gives microporous structure, and higher than that, it gives microcrystal. And our industrial experience shows that higher thicknesses of microcrystal chrome, higher thickness of 0.2 microns are preferred for industrial use because not only it gives a better overall performance, it gives good color also. And for that, roughly about 3 minutes of time is suggested to get more than 2.25 microns of trivalent chrome. As I was mentioning earlier, one of the most gray area which now industry is facing in terms of the metallic concentration. Normal metallic contamination which can be encountered are copper, nickel, and iron. Traveling chrome is not a metallic because traveling chrome is a metallic contamination in hexavalent chrome. Here is not in contamination. So suppose they are increasing more than certain ppm level, I will come down to what is the tolerance limit later on. It will give loss of covering power, black striation, discoloration, and white spots. So that is one gray area now for the tolerance to metallic impurities for traveling chrome. And for post plating also, since it doesn't have ability to protect unplated part, in case suppose the 100% of the surface agent doesn't require chrome plating, so this will have a problem unlike the hexavalent chrome plating. That's why the pH, because of acidic nature, and hexavalent chrome will form some passive layer. That is not the case with the traveling chrome, and that's why you should have a water should have pH of more than 7. And of course, there are some post dips also developed nowadays, which can eliminate the corrosion aspect on unplated surface. Now coming back to the basic chemistries which are now in operations and progressively finding more and more use is the chloride base and sulfate base system. Just to tell you briefly, chloride base means, see now it is not containing, by definition it is not containing chromic acid. So what it contains? The chromium bearing compounds. In chloride base system is the chromium compound logically. And in sulfate base system it is a chromium sulfate. So these are the two basic chemicals, two basic chemicals which are providing chrome, source of chrome. So the most common as an out of these two processes are the chloride base system. I will tell you why industry is preferring more of a chloride base. So initially I will start with the chloride. This is a typical actual chrome plating plant, trivalent chrome plating chloride based plant that is in operation in Europe. In our authorized Europe based dealer is running this plant successfully for the last so many years. So you can see, unlike hexavalent chrome plating, you need to give air agitation. And jigging also very important, and continuous filtration also recommended, unlike hexavalent chrome. So this is a typical setup. So now coming back to the chemistry, basic chemistry of it. As I told you, there should be some chrome bearing compound. In case of chloride, but it will be chromium chloride. Plus, there is a need of conductivity salts. In hexavalent chrome, chromic acid itself is so much conductivity, there is no need. See, it's a very simple process. Chromic acid, 250 gram per liter, it's got very good conductivity. And that's why you can, resistance is so low, you can give very high conductivity. But that is not the case here. Just to pass appreciable cathode current density, you have to have conductivity salts. So there is need of conductivity salts. They are called base salt. They are present in very high concentration. And chrome bearing compound, which is chromium chloride in this case, as I told you earlier, optimum concentration is around 22. And there are some organics involved here also. Unlike in hexavalent chrome, there are quite many organics involved, which enhances deposit properties, color, throwing power, etc. Plus, still there is a need in chloride bath, there is a need to increase the acidity range, which is not so much in sulfate bath. So there are some chemistry developed. You add those chemicals which will increase the acidity, and weighting agent also is must. Which is not there. They use fume suppressant in hexavalent chrome. Here they use weighting agents. It has got also its role. I will tell you later on what it serves. After the chemistry, what are the typical operating conditions? See, it's a mildly acidic bath, and the main value of chloride bath is that it runs at room temperature. And see, cathode current density, these are the optimum cathode current density I have given, but it is about 30 to 40% of hexavalent chrome. As like in hexavalent chrome, anode to cathode ratio is 2:1, so anode current density also is almost half of what is required for cathode current density. As I was telling earlier, these are the role of various addition agents required, must, what the chemistry demands. So base or conductivity salts are the mainly conductivity improving agents, which will reduce the resistivity and hence allow the rectifiers to pass more current. And there are chromium plus salts. And in actual chemistry, you may not require to add this conductivity salt on ongoing basis. That's why this chrome plus 3, this chrome 3 adjustment is only for replenishment. And good uniformity of deposit. So main technical virtue of trivalent chrome plating against hexavalent chrome plating is the throwing power. You get almost 80% throw in wholesale panel in trivalent chrome plating. Against hexavalent chrome, you may get 60-65%. So having said about addition agents, now replenishment. So you need to replenish bath as the production goes on. So these are usual plant level precautions of maintaining bath pH, specific gravity, operating temperature, ensuring the proper maintenance will give you good quality. And here in trivalent chrome plating, you need to base your addition on ampere hour. That I will tell you later on how the addition agents are required to be added based on the electrochemistry principle. So once you add those 3 agents, you record what was the ampere hour, and say normally 1 kAh is passed, then they should be repeated. So that will help you to maintain the bath chemistry at the optimum level. You can do some empirical tests also. Nowadays, all platers also got small wholesale. They need not every now and then give their bath sample to the supplier. They can also implant wholesale also. That also helping to guide whether any specific acid extender or some makeup additive is required. Now coming back to anodes, here there are high purity graphite anodes are used. One of the main advantages of trivalent chloride based bath is the relative cost of graphite, which is quite cheap. And just to pass, say roughly about 14 ampere per dm square of anode current density, or around 7 ampere per dm square, which is half of the cathode current density, 2-inch diameter graphite anode will suffice. And there are Indian manufacturers who can give high purity graphite anodes in a circular solid form. And titanium anodes are preferred because they're acidic. So titanium hoops, they are preferred. Unlike a nickel plating bath, you don't require anode bags here. There is no need. So regarding equipment, here, see this trivalent chrome plating bath very much resembles like a nickel bath in terms of operation. You require mild aeration. Continuous filtration is very much recommended. And even though it's running at room temperature, but for very large installation, more than 5,000 liters or so, the current passed is quite high. So by Joule's law, there will be some heating. So it is very much preferable to maintain temperature at 30 degrees centigrade or maybe 35. More than that during summer, if you are passing more than 5,000 ampere, which is 1 ampere per liter, there can be heating. So that's why the cooling will be required. This is also one more typical agitation plant. Is the actual plating plant working in Europe, where we are supplying chemicals. So now coming back to sulfate electrolytes. So like chloride also, trivalent completing bath require complexing agents, chelating agents, without which it will not function. So they are also part of the overall sulfate based system. And so sulfate also is no exception for that. So chemistry is more or less same. Of course, some organics will change because the bath chemistry, basic sulfate and chloride, it should be compatible to the sulfate chemistry. But here the concentration also will vary, but more or less type of additives are same. Chemistry behind the principle behind these two chemistries, but the formulations are same. Here also carrier additives, both mainly organic based products. Stress reducer also there, because in chrome plating there is always bound to have some internal stress, which is more in hard chrome plating. Here also you get some stress. So stress reducer are there, and mist suppression will be required. Same mist suppression will be required in both cases. These are the typical concentration. So I am refrained from using any trade name, but they will be required. Like chloride baths also, there are different operating parameters to be maintained. Is slightly more high pH is required, but this bath has to be operated some 45 to 50 degrees centigrade. Since the sulfate has got low conductivity compared to chloride, the limiting cathode current density is also lower compared to chloride bath. So maximum you can pass is around 12. Above that you can get burning. You will not get acceptable deposits. So these are typical acceptable operating range which I mentioned. And filtration also like chloride bath, it will be required. The same chemistry principle which I mentioned in chloride are applicable here. Here there is also chrome-based salt, mainly containing chromium salt, chromium sulfate. And the only chromium sulfate-based salt is required for replenishment. For fine makeup, it contains so many other ingredients. For maintenance, you require only chrome-bearing compound. Plus, there are some carrier additives which enhances deposit properties, throwing power, color, etc. And stress reducer as well as mist suppression. Here, the mist suppression nature is chemistry somewhat different than the chloride, but the function is same. It gives good throw at low current density area and uniform deposit. Here, they use very special chrome anode. That is impediment many times in easy adaptation by the industries. They use what they call it MMO, metal oxide titanium anodes. In industry parlance, they are called green chrome anodes. And there are a handful of manufacturers worldwide, none in India. Iridium oxide, cerium oxide, they are very costly. Those anodes are about 7 to 10 times costly compared to the graphite anodes. And here also, because of sulfate chemistry, you don't need to pass more than 6 ampere per dm square anode. Like chloride bath, you don't require anode bags here. So now, having explained you the pros and cons of sulfate versus chloride, any industry, any wants to adopt, which one they should go, chloride or sulfate? And these are the common questions they will ponder upon: SCD range, color, LCD coverage, plating speed, waste treatability, and all that. In practice, both are successful. They can be operated for a long period of time, provided they kept proper housekeeping, proper maintenance of the bath, and ion exchange, which then they can be run for a very long period of time. So both are in operation. And there are many suppliers for that. But coming to the color, see, because we are used to bluish bright finish of hexagonal chrome for decades. So naturally, there is still a perceptible change between, if you saw what is how the color of trivalent chrome plated bright nickel part looks like compared to hexavalent chrome. So color wise, chloride electrode plates slightly whiter. Of course, plating speed also, chloride will give, because of higher limiting cathode current density, chloride will plate much faster than the sulfate. Right, the waste treatability, both has the same, both contains trivalent chrome, so that has to be precipitated by addition of proper ETP process. See, these are the components which I mentioned: makeup, replenishment, the operating temperature for sulfate and chloride. You can compare side by side. Main difference is the cost of anode here. Otherwise, more or less both are same. This is the thing which might a prospective customer would like to know, the relative cost. Here also, operating cost, equipment, makeup cost more or less same for the both, but only the anode cost is quite high. Still, for operating cost, you require something. Both are same, so they will eventually even out. So this is the conductivity solved. I have given chloride bath has got more conductivity, so that's for more speed also. This you can note down. These are the main metallic tolerance limit level one has to guard with. This is the final summary. So there is no clear-cut answer which one to pick one. That is to be based decided in conjunction with the supplier and the customer. Thank you for being present.
Thank you, Mr. Shah.
Thank you very much for your lovely delivery. What's up next?
Now, our next speaker is Mr. Rakesh Kumar Bhan from Fisher Measurement Technologies India Private Limited, Pune. The advancement in measurement of coating thickness. Now, I'll just give a little brief about Mr. Rakesh. Mr. Rakesh Bhan is the Managing Director of Fisher Measurement Technologies India Private Limited and Fisher Instruments Middle East FEZ CO, Dubai. He holds a BTech degree in electronics and MBA marketing from Pune University. Mr. Bhan joined Fisher India in 2008 as a general manager and has since played a very pivotal role in building and expanding the business across the India, the SAARC countries and the MENA, Middle East and the North Africa region. Under his leadership, Fisher has strengthened his position as a leading supplier of high precision instruments and solutions for coating thickness measurement, material analysis, material testing, and micro hardness measurement. With over 25 years of the professional experience, Mr. Bhan has worked with both Indian and multinational organizations, gaining a deep expertise across a wide spectrum of industries. His core competencies include the profit center management, international business separations, strategic business development, key account management, and the successful establishment of the large market footprints in India and abroad. Mr. Bhan technically expertise spans machine tools, analytical instruments, spectroscopy, surface and coating analysis, inline measurement systems, and industrial process automation. He is known for his thought leadership and the insight presentations on emerging technologies, particularly in the domains of coating thickness, micro hardness, industry 4, and AL-driven surface measurement solution. A frequent guest speaker of leading industry platforms such as CII, MFAI, SSPC, and Corcon. Mr. Bhan is widely respected for his ability to bridge the gap between the cutting edge technology and the practical industrial applications. Mr. Bhan, please.
Hello. So, good afternoon, ladies and gentlemen. Thank you, Mr. Paliwal, for the introduction. Uh, I think we all have gone through the various sessions since last 3 days, and all these sessions mostly have been concentrated on different coatings, the nano coatings, the new technologies, the processes. And today I am here basically to touch base on to measurement of these some of the parameters of all these coatings, which is very equally important because when you have done certain coatings, effective measurement of those coatings and is very, very critical and important. Yeah. So just basically, as I mentioned, some of the physical properties of the plating. Plating thickness, as we all know, is very important because we are doing plating for certain enhancing the properties of the material. So the effective measurement is also critical, because if it is too thin, then it will not provide you the enough what you call resistance for the corrosion for which it has been plated. Similarly, the longevity and cost of the final product also depends on the amount of coating that has been applied. So the right measurement of the coating plays an important role. So there are other properties of the materials which also needs to be measured, like we have adhesion, then we have hardness of the coatings, especially very important in case of some of the coatings like hard chrome or PVD coatings. And similarly, we have chemical composition of the platings, because nowadays there are a lot of platings wherein we are using composition of the plating. It's an alloy coatings, not a single coating. Like for example, electroless nickel, a lot of people have been talking about that. Then we have zinc nickel. So here, not only the thickness, but also the composition of basically nickel and phosphorus, or similarly zinc and nickel, plays a very important role. And corrosion resistance at the end also is very critical and important, because that's what decides the life of the final product. Since we don't have enough time for this section, so what I will concentrate mostly will be on coating thickness measurement, and touch base also on some part on the hardness part. So like when we talk about coating thickness measurements, there are multiple technologies which are available. Some of them are destructive in nature, most of them are non-destructive in nature, and one of them we can say semi-destructive. These are some of the technologies which I will touch base on during this presentation. One of the widely used and most prominent and very versatile technology is EDXRF. Yeah. So a lot of applications are based on this technology, which is a measuring method wherein actually if you see this three figures, everybody in the physics, we must have heard about atomic structure. You have an you have an atom, and then you have electrons which are revolving around that. So what we do in this EDXRF, we target these atoms with an basically an X-ray beam, and this gives energy, for example, to some of these electrons in the K shell and knock them out from this orbit. Now to fill up this gap, an electron from the outer shell falls into the inner shell, and during this transition, there's a release of energy which we call fluorescence. And by physics, we know when for a particular metal, when an electron falls, for example, from K shell to the L shell to the K shell, the release of energy is known by physics. So what we do in XRF, we have basically like this, you have an X-ray tube which passes this X-ray beam. There are some primary filters basically to optimize this X-ray beam. And then we have video cameras basically to ensure where we are doing the measurement. And then we have aperture. Aperture is basically a small opening through which you are targeting the X-ray on a particular spot of your sample. And as I said, this process happens inside your metal on the material. And these are the fluorescence lines. These fluorescence lines then are detected by a detector. There's a detector which detects which all energy lines are coming. So that with the help of that, it gives you basically measures how many metals are present in the sample for analysis purpose. And the intensity with which these fluorescence lines are coming, like these peaks, it decides basically the concentration or intensity of those metal present in the sample. These are basically happening at the background. What you see directly onto the electronics or in the software, you see directly the thickness or the concentration of the basically particular element which is present there. So there are a lot of advancements which are happening basically in the XRF field as well. In the past, we were using proportional counter detectors, which could actually detect only few metals or which could only work with few materials. Also, it was important in proportional counter that the elements had to be quite far off from each other. But with now SDD detectors coming into place, we are able to achieve very high absolute standard deviation with the same measuring time as compared to the proportional counter. Or alternately, you can reduce your measurement time by a factor of 3 if you want to keep the same standard deviation. So this is possible because of very high count rates which we are able to generate with the help of silicon drift detectors. Also, there's a digital pulse processor technology which is now taking these pulses from the detector and processing it much faster as compared to the analog processors which we had earlier. For example, I just given one of the examples of the platings. You can see so many applications within a motorbike. For example, these are some of a lot of applications where we have zinc, nickel, zinc flake, dachromat. We have chromium, sometimes chromium nickel on MS, nickel phosphorus. So you can see so many applications are there which can be easily measured with the help of an XRF. So that's a big advantage with XRF, that any metal coatings which is there on the base metal, it can be easily measured with the help of XRF and in a non-destructive way. Some of the applications for or the industries where you can find these, where the XRF finds an application, whether it's a precious metals, platings, electronics and electricals, like a lot of work is happening now on the electronics field or as well as in the semiconductor field. So we have solutions also for all these kind of applications. Automotive anyway is there. So you can see quite large number of industries finds an application with an XRF instrument. Also, one of the typical applications for XRF is an ROS application. There's a restriction on hazardous substances. As you know, while exporting, there are certain restrictions on certain materials, like we have lead, mercury, hexavalent chromium, which we have been talking earlier, then some of the bromine components and the cadmium. So XRF is a very fast and efficient method of screening, basically to check faster for these kind of elements, if it are present in that one. So it basically gives a screening method. It's not a final one, but if you get a result which is below the limits, then you can easily say that it is passing the RHS limits. And on the other hand, if it shows you also on the higher side, then again you can reject that one. But in between, if it finds, for example, if it is 100 ppm of cadmium, now we have a tolerance band of 30 plus and 30 minus. So that means if anything between 70 to 130, you have to go for further tests. But anything below 70 is measured by the XRF, you can easily pass it. And anything above 130, you can easily say it is failing the test. So it's a much faster screening method because there is no preparation required as compared to the other methods. So again, for the EDXRF, as I said, advantages, as I mentioned, it's a very versatile instrument because you can measure anything from aluminum till uranium, any metal in between. It can be measured with the help of this one. You can do multi-layer coating thickness measurements after all the coatings have been applied. Then composition analysis of the alloy coating, which I mentioned, nickel phosphorus or zinc nickel. Bath solution also one of the application, like you want to know the concentration of your bath while the plating is happening. With the help of XRF, you can do that. RHS screening, as I mentioned, is also possible with this one. And it's a very accurate method and a non-destructive nature. That means it doesn't change the integrity of your sample at all. And also literally suitable for all kind of metal coatings and substrate combinations. Even can be used for very thin coatings, which are coming up now, especially in the electronics field, especially in the gold market, where you are coming now into nanometer levels. Coatings are making way in the market, and this can be easily done with the help of XRF. And also can be used in very small areas. That's also important, that with the help of like in semiconductor industries where the spot sizes are very small, we work with polycapillary based instruments where we can go down to 10 micrometer level of measurement spot, yeah, which is very, very critical in these kind of applications. Some of the limitations, as we have limitations in all the technologies, is that if you have very thick coatings, then there comes some limitation that after a certain thickness of the coating, which depends on the density of the material, it cannot penetrate further. And similarly, in those cases, if there are multiple layers and the coating on the top is of high density, then the coatings beneath becomes difficult to be measured with the help of this technology. So that was about XRF. Now let me come small on the tactile or the handheld instruments, which is again quite widely used for a lot of plating applications, single platings. So here we have multiple instruments, basically which work on magnetic induction method or eddy current method. So if you have a base which is magnetic in nature and a coating which is non-magnetic in nature, you can easily measure with the help of these instruments. And similarly, if your base is conductive in nature, like non-ferrous metals, and the coating is non-conductive in nature, it can be easily measured with the help of these instruments. But mind it is used only for one single layer. You have multiple layer thickness in this one. So one of the also the typical applications which we have, for example, with we call a phase sensitive eddy current, that it can measure at duplex coatings. So a lot of corrosion industries like bridges and all, we have basically iron and steel as the base. There's a small layer of zinc on top of that, and then on top of that they do lacquer. Also one of the typical applications you find in the car industry, where basically the car body itself is of stainless or a mild steel with a small thin layer of 7 to 8 microns of zinc, and on top of that they do the coatings of lacquer and paint. So the zinc coating is very critical, so it should be measured separately. So with the help of this phase sensitive, you can separately measure zinc and lacquer in the same measurement. Again, latest advancement which have happened in these instruments, like these instruments are now coming with a IP64 protection. Then you have rechargeable batteries inside that one, plus a USB-C connectors are giving with the probes and all, so that it can be easily repaired and all those things. And also transfer of data can happen to the Bluetooth to the directly to the data center, where you can generate your reports. Advantages, as I mentioned, they are non-destructive nature, again, relatively low cost as compared to the XRFs, fairly accurate and repeatable, and instantly you get a digital display on the display. So one of the limitations is, since these basically depend on your placement of the probe, so it cannot be used for very thin coatings. So roughly we say 2.5 micron plus, it can be easily utilized for this measurement. And again, if there are multiple layers of the same coating, like paint, if you have 3-4 layers, it can measure the total thickness. It cannot differentiate in the same coating with the help of this one. Very general applications like paint, epoxy, anodized on the aluminum, similarly adhesive coatings, zinc, chrome, cadmium easily can be measured with the help of these instruments. One more method which we call a coulometric method, again quite widely used in a lot of plating industry, which is more of kind of a equivalent kind of a, say, you can for an XRF, but at a relatively lesser cost, is quite widely used. Coulometric method, basically it's a reverse of plating. It depletes a small area of the plating, so that is why we call it as a destructive nature, because it will create a small spot on your final sample. So again, very widely used. It can go up to 3 layers. Like you can measure 3 different layers with the help of this method. One of the very typical applications of coulometric method is a step test, because we know there is we do basically a chrome and then a tri-layer nickel, and then you have copper at the base. And this tri-layer nickel separate measurement is very critical because of electrochemical difference between the 3 different layers. Now, if you check it with an XRF, you will get the total thickness of the nickel. But whereas in the industry, it is very important to know the separately the each layer of nickel, because that's where it gives you the corrosion resistance and it is critical. So with the help of the step tester, we are able to measure 3 layers separately, and along with that chromium on the top. One of the important, actually very good also method is called a beta backscattering method. Yeah, this is basically an application. It works where nothing else works. Like if an XRF, as I mentioned, in the XRF you have a limitation that it cannot go quite deeper. If the thick coatings are thick, they cannot penetrate in the XRF. So here we can use this beta backscatter method, which consists of a radioisotope, which is continuously bombarding the isotopes onto the sample, and the reflected, basically these isotopes are collected by a Geiger-Müller counter tube, and based on this absorption of these these electrons which are targeted on that, we are able to basically do the coating thickness measurement. So sorry. One of the basically, as I said, it's a very versatile instrument, but unfortunately, one of the requirements in this case is basically coming from the ARB. Since it is radioisotope in nature, you need to get a approval from Atomic Energy Regulatory Board. So that is why the processing of the documentation is slightly higher in this case. And if you are having a radioisotope, you cannot just destroy it. The new technology also which we has come up, or which we are now promoting, is basically terahertz. Now this is based on the terahertz principle, where basically what we do is we measure the time of flight measurement between pulse terahertz which are targeted onto the samples. Now this is typically mostly used in case of applications where we cannot XRF cannot work. For example, in the XRF or in case of magnetic induction method, as I mentioned, like in case of car body, there are multiple layers of paint which they do it. For example, they do E-coat, primer, base coat, and clear coat. So generally, they want to know each layer separately because then it depends on that the properties of the whole corrosion resistance of the coating is dependent on. Now, if you use a regular DFT meter, you will get the total thickness of this all 4 layers. But since they want individual layers, that's where this terahertz comes into play. You can easily measure all these layers separately, and very wide application in the automotive industry for this purpose. One more technology which has been added by Fisher or which is available now is called photothermal. This is again a very good application where basically we are exciting the surface with a laser, and based on the heat property or the heat absorption of the material and the time delay of the re-emission of the thermal radiation, we are able to give the thickness measurement based on that one. Again, it's a non-contact, very fast method and can be utilized quite effectively in a lot of applications, especially also very useful in case of process lines. That means use a small head actually, which can be mounted onto the process line, and while continuously measurements, we can do this kind of, you can utilize this method for that measurements. So that was more on the coating thickness, a small overview about the micro hardness. As I mentioned, coatings are again important, but at the same time, hardness is also critical, especially for those applications where the coating is specifically done for enhancing the hardness or the wear resistance of the final product, especially like PVD, CVD, and then we have like DLC coatings or hard chrome also. You can do this kind of this thing. So it is important and critical to measure the hardness of the coating itself, because this is one of the important properties there. So if you use a regular hardness tester, the disadvantage regular hardness tester is that you make a big indent, and so basically what happens is what you are measuring is the base material plus the coating. But where we are interested is only knowing the hardness of the coating itself. So that's why you need a indentation method. Here, if you see here, what we do is we do a loading curve and there's an unloading curve. That means we keep on loading till the final load and then we come down. So we control the force and the depth of penetration in this one, so that we restrict the force within the coating and do not go into the base material. And that's very helpful, and that's why you get the real hardness of the coating and not of the effect of the base material. So this is presented here. For example, as per the buckle rule, for example, with the traditional hardness, when you make an indent, you already get into the base material. Influence of the base material comes in. So this here, the hardness is a combination of the base material hardness as well as the coating. But actually, we are only wanting to restrict ourselves to the coating so that we know the thickness of the hardness of the coating itself. And that's where we do it. For example, when we load it, we see the shift of the curve. That means we are now getting into the base material. So you need to restrict the load now below this curve where the shifting happens. And that's the next time when we do the indent, we restrict the load to this one so that the hardness comes within this range only. Yeah. So very effective for these kind of applications. As I mentioned, the advantages are because precise results, because the fully automated one where you can get the complete readings, not only the hardness measurement, but you also get other properties of the material like creep and elastic and plastic properties of the material. Similarly, all these instruments can be utilized in the automation. That means if somebody wants to automate the processes where they want to check online measurements, this is possible with Fisher. All these components can be utilized within your process, and we can take the data from the field and take it to the upper levels. Like for example, here we have shown, here is a reel-to-reel measurements where you can do the continuous measurement of reel actually while it is being plated. So latest in the products what we have utilized again, which is might be quite useful for the industry, is basically liquid analyzer. So generally we know as in XRF we can do the liquid analysis, but again you need to go to the bath, you need to take up the sample, go to the lab and try to measure it there. But here what we have done is we have automated this process. That means this instrument can be put into your process itself. It will, the pipes are directly connected to your baths. It picks up the sample directly from your bath and brings it to this instrument where it analyzes and again discharges back to the tank. So there are 4 channels available. That means 4 different baths can be analyzed simultaneously with the help of this instrument. So quite widely used, especially for precious metal analysis. You can easily use this and have a control on your processes. So yeah, in the conclusion, as I said, a lot of instruments are available, tools are there, which you need to utilize to improve your processes. EDXRF being one of the important ones, the micro hardness which we have done, and plus, as I said, with the latest SDD detectors, and a lot of opportunities are there where we can do the precise control of your materials and all, especially like precious metals, gold, silver. You need to have a very clear tolerances where you need these instruments. So this is a small overview. As I said, we have XRF, tactile, terahertz, and nanonotation, plus the automation. So if you have any questions, please feel free to come to our booth. We are there to help you out. So thank you all. Thank you for your attention. Thanks a lot.
Thank you, Mr. Rakesh.
Thank you.
Thanks a lot. Now our next speaker is Dr. V. Ravichandran from Sartime Horological Private Limited, Zero Liquid Discharge, ZLD by Dr. Ravi. A small brief about Dr. V. Ravichandran. He is a PhD in Chemical Engineering, University of Notre Dame, USA, 1981. MS, he has done Chemical Engineering, Oklahoma State University, USA, 1978. BTech, Chemical Engineering, University of Madras, India, 1977. He is a Director Technical from 1989 till present at Sartime Horological Private Limited. Assistant Professor, January 1985 to 89, Department of Chemical Engineering, IIT Madras. Assistant Professor, December 1982 to 84, Department of Chemical Engineering, IIT Kanpur. Visiting Assistant Professor, September 1981, May 1982, Department of Chemical Engineering, University of Notre Dame, USA. Research Assistant, November 1978 to 81, Ford Motors Company, Dearborn, Michigan, USA. Research Assistant, September 1977 to 78, Fluid Properties Research in Oklahoma, USA. He is a recipient of 2001 DuPont USA Corporate Sustainability Excellence Award. Mr. Ravichandran, Dr. Ravichandran is a specialist in environmental engineer with over 35 years of experience in design, operation, and the management of technology changing chemical and the environmental projects. 5 technologies were invented and implemented towards the waste minimization and recycling in the industry. Activity participating in CII in their EHS committee, pioneer in ZLD projects for pharma and auto industry. His area of expertise is basically in environmental engineering, industrial waste minimization and recycling, design and operation of chemical process plants, zero liquid discharge systems, membrane bioreactor technology, sustainable engineering solutions, and he has a lot of key achievements and innovations, especially recycling of TDI drum wash water, degreasing bath life extension, online phosphating sludge removal, compact maturity measurement device, distillery wastewater mixing equipment, MBR for API wastewater treatment, and all this is a professional engagement, especially the active member of Confederation of Indian Industry CII, contributing to the Environment, Health and Safety EHS Committee. Thanks. Thank you, Doctor.
Thank you very much, sir. It was a 300-word introduction. I wrote up to 295. Thank you very much. I will try to be a little brief next time around. I really enjoyed MFAI. This is the third time I'm coming. Earlier I was in Bombay. Maybe I'll try to come every year because I thoroughly enjoyed the last 2 days I was here. My topic today is zero liquid discharge. Already 2-3 speakers earlier to me has spoken some of my topics, like how to minimize wastewater in the industry, which I have been working, and how to minimize chemical consumption in the industry. Reduction of wastewater generation or reduction of water usage in the industry and minimizing the chemical reduction are the backbone of how we can achieve zero liquid discharge. If you put more water and if you put more chemical in the waste, achieving zero liquid discharge is very difficult. Okay, we started in 1988. I've already gone through it. Now, we study the process. That's very important. When people call me, okay, give me a effluent treatment plant or zero liquid discharge, we don't ask them what are the parameters. We go and study the entire system, like a doctor diagnosing your disease. And we develop our own strategy. Our own strategy is source reduction of chemicals. For example, we have plants working now where the alkali degreasing is not discarded at all. Most of the plants I visit, they say after 2 months we discard, after 4 months we discard. Just do a little bit of change in the formulation. You can keep the alkali degreasing forever. We also try to avoid transferring the bath and cleaning the tank. That again, you lose chemicals. So we very strong, no oil should come to the effluent treatment. The moment oil comes, the entire treatment becomes a problem. So like Ayurvedic, if you go there, he'll put a lot of conditions before you take the medicine. We put a lot of conditions, then only we take up the ZLD. That is where we are very successful. Now, what do we mean we are very successful? We are very successful in the sense we recover 95% of the wastewater. And it's working in Royal Enfield. There are 3 plants and pharma also, Mylon. We have done around 30-35 plants now. Everywhere we give 95% plus water recovery. And then we give all grades of water, recycled water, no fresh water. We have a policy that when we go into a factory, fresh water is used only for human purposes. For any process, we can give whatever grade they want, the wastewater. Then reduction in water consumption. We had a Polish speaker morning about reducing the rinse water. We have been practicing for the last 15 years. We have more than 30 customers where we have reduced the water consumption by 30% to 50%. But I won't be talking, we don't have the time for that. Okay, what is the ZLD? Achieving ZLD in many factories is not easy. So what is the criteria for achieving 95% water recovery in the RO plant? One is the fouling of the membrane should be reduced. Fouling of evaporator must be reduced, and the evaporator feed must be reduced. So if the membranes don't foul, you get high recovery. If the evaporators don't foul, you get low energy consumption. And if you get high recovery, your flow into the evaporator is reduced. This is the whole strategy we are following, and we have been implementing also. Now, around 15 steps we implement, but I'll be discussing only 3 steps because I have a limited time. Maybe we can discuss that later. One is the 4-step strategy, which I just discussed. Second is the chrome reduction in the pipe reactors instead of open tank SMBS acid addition. Third is the jacketed evaporator in the place of calandria evaporator. There are other things like how to increase the OBR of DM plant, and nanofiltration in the place of softener, and high performance coagulants rather than using blindly sodium hydroxide lime or something. We can use high performance coagulants. There are 15 types. I listed only few. And what are the latest developments in ZLD? The 4th step is normally the wastewater is, everything is mixed together, and then you are given in a collection tank, do everything, be it CED paint, be it alkali degreasing, everything is mixed together and you are asked to treat. The chemistry is different. If there's a CET paint waste, it's an organic waste. You have to use a different chemistry. If it's a pre-treatment waste like phosphating or degreasing, pickling, it's an inorganic chemistry. You can't mix both and then say treat. So we do source reduction, source study, which is related to source reduction, where water is conserved, chemicals are segregated, and chemicals are reduced. And then we go for the next 3-step operation. Now, on the left side, in the top, yeah, here there are two triangles given. One is inverted, the other. The pollution is the maximum at the start. As you go down, the pollution decreases. But if you take the energy requirement or cost of treatment, it is the lowest at the start. Then as you go up, the cost of treatment increases. That's what I have mentioned. The first 2 steps, like source reduction and ATP, we are eliminating the pollution. And the cost is only 5% of the overall cost. But in the next 2 steps, like RO and evaporator, we are only concentrating. And the cost is also very high. So if you concentrate more on eliminating the waste, then the cost of concentration reduced. That is why all my customers are repeat customers and they come back to me because they are very happy and they run their evaporator only 3 days a week or 2 days a week. This is, and now I'm getting into some of the technologies we follow. This is the inline chrome reduction treatment. Normally, there will be an open tank, you put acid, reduce the pH to 2, then add SMBS, and a lot of SO2 will come out. Here, we are doing everything inside a pipe. Because of the confinement, no SO2 is escaping out. All the SO2 is reacted. That way, we are reducing the SMBS consumption by 60% and also the acid addition by 60%. This is the flow diagram for that. Now, second is if you use the pipe reactor, the space requirement is also reduced. Instead of flash mixer, flocculator, and all those things, you can do it inside a pipe. This is another setup for that. It is just done right there. Everything is automatic. No worker is there to monitor. This is the next I was mentioning about the reactor. This is a no maintenance required. It's a manpower-free evaporator. Since we are getting 95 to 98% recovery, the volume typically a major automobile company will have an effluent of 300 to 400 meter cube per day. So the effluent will be around 15 KL for evaporation. So instead of using calandria, we are using this type of evaporator. So no calandria to get foul. The next slide I will show you. These are the tubes through which the hot water flows in the evaporator, and these are the tubes which get foul. So if you don't have these tubes, then there is no question of fouling. these are all just vessels with a mixer inside, and fouling does not take place at all. And these are fit and forget type evaporator. Everything is automatic. The moment the level comes down, automatically the feed is given, and the steam is adjusted automatically. So no manpower is required, no maintenance is required. Once in 3 days, we open the vessel opens automatically, and the salt is discharged. The problem with Calendria is two. One is this Calendria, as I showed you, the pipe which gets fouled. Second is the recirculation pump. The recirculation pump is in high temperature and high mechanical seal, and it breaks down very often. So once the recirculation fails, the Calendria gets fouled. So this is what I told you. This Calendria, because of the tube size, it gets fouled, especially if you have a low volume like 15 meter cube per day. This Calendria is a no-no. And we don't use cooling tower because many automobile companies don't need a cooling tower. If it's a pharmaceutical company, it's very common. We can draw from the common cooling tower. So instead, we go for air-cooled heat exchanger. So you have no fouling in the evaporator, you have air-cooled heat exchanger, everything is automatic. So no manpower is extra required there if you go for this jacketed tubeless evaporator. This is the salt you get from the evaporator. This is the type of crystals you get from the evaporator. Now let me go to some of the latest developments we do in the ZLD area. Now, if you look at the effluent treatment or ZLD area, all the elements are the same. You have a treatment scheme. You have the effluent treatment. This is a CD paint treatment for Royal Enfield factory. Recently, actually, this is a CD paint for Eicher Motors in Bhopal. They are making electrical commercial vehicles, recently completed. And the treatment process is same, RO plants are same, and this is the ultrafiltration system, this is a sand filter system. But then what is new? So if the currently what we are doing is we are replacing the treatment tanks because the intermediate treatment tanks occupy a lot of volume. So we are replacing them with what is called process intensification. So instead of using flash mixture flocculator, we use static pipeline, inline flash mixer and flocculator that practically reduces the volume. So earlier you require 10 tanks, you require now only 6 tanks. So it reduces the footprint, capital cost, and manpower because more tanks means more manpower is required. So this is the, I'm just comparing the process intensification between Calendria and jacketed vessel. The footprint, you can see the footprint. It's only 70% in the sense you also have a mezzanine required here, which is not required there. So substantial footprint reduction takes place. Now, instead of going for circular tanks, if you go for square tanks with common walls, again, you save, not only save space, you also save on capital cost. And many of my customers keep expanding. So you have some area, and if you keep expanding, suddenly you run out of space. So again, we try to club the equipments together. And here we have put the UF and RO plants in the same skid. Normally, it's a different setup. You will have different equipments, but you have put them on the same skid. And the intermediate tank also is avoided here. That's again saves space. You can see practically, like in a submarine, you can only have 2 feet to walk around or 1.5 feet to walk around. Because the company is expanding, there is no space available. So we use what is called process intensification. And then this is, we use, normally people use one type of membrane in one skid. We use multiple membranes to optimize the energy and recovery. And this is the SCADA of, I think it's a Viatris means it's a pharmaceutical company, but we have a similar one for Bhopal Electric Vehicle Eicher Motor Factory. Recently, we use a lot of SCADA because manpower is a problem and also recording the operation is a problem. So these are the SCADA of these automation systems. And I'm just trying to finish fast. We use permeate RO scheme to increase the OBR. I'm just giving one example here of the DM plant. Now, what is the reason for that is if the OBR is very low, every day you have to do regeneration. If you have to do regeneration every day, then the salt, a lot of salt comes out as a waste. In all my plants, the OBR is 1 month. We do more of RO before we go to DM. In RO is a physical separation. Whatever the chemical is there, it is physically separated. So no extra chemical is used. Whereas if you use DM or resin, for example, for every 1 kg, you generate 2 kg of waste. That again adds to the ZLD, adds to the evaporator. That is why in earlier I mentioned we don't use softener at all, softener resins. It's completely banned because the moment you use softener, they are generating 100 kg of salt every day in a solution, and this has to be heated, evaporated. Instead, we can spend a little bit more money on softener membranes like nanofiltration and reduce the load on the softener. Recently, in one factory in Gujarat, we have reduced 300 kgs of salt by replacing by membrane. Imagine. And I don't know how they dispose the 300 kgs per day. So use RO membrane as first source elimination is important, which is the easiest way. Then comes membranes, and then only you go for the treatment. Thank you.
Hello. Thank you, doctor. Thanks for your nice presentation. Hello. Now our next speaker is Mr. Aditya Joshi from Chemtech Surface Finishing Private Limited. Future trends in zinc and zinc alloy coatings. Okay. And Mr. Sanal Kumar, also from Chemtech Surface Finishing Private Limited. A short brief about Mr. Aditya Joshi is the President and Director Technology. Aditya is a chemistry graduate with a career spanning 45 years in metal finishing industry. His majority part of career has been with Autotech. 2017-2021, he was the Director Technology at Autotech. 2001 to 2017, R&D and the product development functions and supporting business development functions at Autotech India as a part of top management, Senior General Manager, Technology and Analytics since 2010. From 1984 to 2001, Aditya worked with Megan Rocco India, stroke Platteville for 17 years as a in charge of technology and the business development. Prior to his, he had a brief stint with Groveronville, India, and other companies, Indian metal finishing industry. Thank you, Mr. Joshi. And Sanal Kumar, I think you please brief yourself.
Introduce himself.
I'm Sanal Kumar. I'm a graduate from University of Kerala. I started my career in 1989 in surface finishing industry and worked with. I started my career with Groveronville, and then I was a member of the initial team of Artec when it started. In '96, when Atotech started, I was a initial member from '96 to 2021. I was with Atotech. 2016, I moved to Singapore. I was taking care of Indonesia, Philippines, Singapore, and Malaysia as the managing director of Atotech Southeast Asia. And 2021, we started our company, Chemtech. Thank you. Hmm? Yeah. The last session, though it is not, it's an important session where when we start talking, before start the presentation, I would say something about alloys. So we have a marvelous thing in 4th century in Qutub Minar. So that 4th century created around 1,600 years before the alloy created, which is still not corroded. So as I understand, that's having an alloy of less than 1%, around 1% of phosphorus, and it got some like oxidation, some passive layer which is created on the surface, which prevented any further corrosion. So if you are able to create that kind of alloys, probably around 35% of the global GDP will be saved, because that's a rough figure which is spent for preventing corrosion. So when we talk about zinc and zinc alloys, this is a alloys, as I just mentioned about the alloys can do wonders. Like 1600 years, if the alloy can withstand from corrosion protection, we have not explored the total potential of alloys. So research are going on, and one of the friendly material is zinc. So the key drivers for alloy, it's sustainability. So obviously everywhere, anything we talk about, that sustainability is the most important thing to be taken care. And the performance, smart manufacturing, which will be more and more relevant in the coming days. This is for automotive, aerospace, energy, and AI. So why we need to have different kind of alloys? Yeah. So the industry challenges, extended corrosion warranties, EV durabilities, thin coating. Like in the past, to extend corrosion resistance, we used to go for very high thicknesses. And with the alloy, different kind of alloys, we can go for thinner deposit. That's a requirement of the industry today. So environmental compliance pressures. So these are the key drivers for performing alloys. So zinc remains as a strategic metal. I would say around 30 years back, if we talk about the electroplating industry, zinc used to be a very small portion of the total electroplating surface area produced. That has been changed. Those days, it was hard chrome was for functional application, nickel chrome was other major part of the electroplating done. But over a period of time, corrosion protection become more and more relevant for different industries. Now that way, the zinc become more reliable, more relevant for the industry, and that's importance are becoming more and more usable in the industry. Economical, and it's a sacrificial layer. This is that's a cadmium is a material which is none of us want to use because of the environmental issues. So it's a replacement for cadmium with the alloying with the other metals. Multi-process capability, acid solutions, alkaline solutions, and it's environmentally acceptable. Zinc supplement that we use as a medicine. Evolution engineering alloys are zinc iron, zinc cobalt, zinc nickel, tin zinc, and zinc aluminum as a zinc flake. So the improved corrosion resistance and heat resistance and enhanced durability, a life cycle performance. These are the major advantages we can get from these alloys. So when we talk about the corrosion protection performance, acid zinc give us 120 to 240 hours of neutral salt spray. This depends on the thickness and the passivation and the top coat being used on it. Zinc iron can give us 240 to 480 hours of salt spray. Zinc cobalt 300 to 500 hours of salt spray. Zinc nickel from 12 to 18 micron. I am mentioning only the medium one. There is also a low composition, low percentage of alloy. So 12 to 18% can give us 720 to 200 hours, or maybe even 1500 hours can be achieved. So automotive and aerospace adoption, safety criteria in fasteners is compelled to go for highly performing alloy materials. Brake system and underbody parts. As the life of the end of the life vehicle has changed and now EV is getting in more and more prominence, end of the life vehicle will not be applicable for EVs. So you need to have a highly performing, high corrosion resistance part. When we talk of initially the brake calipers used to use acid zinc plating. Now most of the areas the acid zinc plating is replaced with a zinc nickel plating, alloy plating. Aerospace fittings, very high corrosion resistance performance is required. So high heat exposure components and data center infrastructure, which is actually a highly growing area today with the AI relevance is increasing day by day. So commercial plating, electrolytes available for acid zinc plating, cyanide-free alkaline zinc. Cyanide zinc is almost disappeared from the industry and it's not a preferred process, so I don't mention it. Zinc cobalt, acid electrolyte, alkaline zinc iron, alkaline zinc nickel, acid zinc nickel, and tin zinc. So these alloys, the alloy platings comparatively the pure zinc plating, much higher performance with the alloy compositions. Passivations and sealers are there to enhance the corrosion resistance on top of the electroplating. Trivalent chromium, hexavalent chromium is again is not being used. It's almost disappeared from the industry. Cobalt-free systems is a new requirement which is already in use for several applications. Salient-based sealers to enhance further corrosion resistance on top of passivation, and control COF requirement mainly for fastener applications. Sustainability transition, Chrome 6 elimination, which is almost done by the industry, except very limited aerospace or defense application. Nobody use hexavalent chromium passivation. REACH and ELV compliances, low toxicity system. So high performance black passivation system. In the past, for very high performance olive green passivation is being used because olive green is the thickest passivation which can give the highest corrosion resistance. So by the elimination of hexavalent chromium, no replacement, or blue passivation, iridescent passivation, black, everywhere we could find alternate with the trivalent, whereas we could not find any alternate till date for olive green passivation. So olive green passivation is being replaced with now black passivation. So black passivation which can give a very similar thickness compared to olive green passivation. It's a single stage trivalent black passivation is still under development. The best performance, it is being used as two-stage system, the passivation and the finishing. This give a thick passivation layer of 0.4 micron, including the passivation plus the sealer finishing layer. This is heat stable appearance. This have an ability to keep the finish before and after the heat treatment. It can, with bake and without bake, we can retain the same brightness and the gloss levels. This is suitable for baked parts, that's hydrogen de-embrittlement part. Some pictures of the corrosion resistance of the thick black passivation, 72, you can see that 72 hours, 168 hours and 240 hours without baking and with baking. So you don't hardly see any difference in this. This can also provide a solution for cyclic corrosion test validation, heat and quench test, and performance retention after baking. So hydrogen embrittlement control, it's a risk of high tensile stress more than 100 MPa. Control acid activation, if we cannot eliminate the acid activation, but acid activation always introduce hydrogen into the part, and which can lead to breakages in the field line. So controlling acid activation inhibitors to prevent optimized current density to enhance minimum hydrogen incorporation. So post plating, baking, which will help to remove the embrittled hydrogen, and process validation as per OEM specifications. And corrosion protection mechanism, zinc alloys give sacrificial protection. Zinc become anodic, and the cathodic protection to the substrate where it is being deposited. So barrier protection via passivation. Zinc nickel forms a stable corrosion product and the reduced white and delayed red rust. So when we say with zinc, we can achieve 240 hours of white rust and 480 hours of red rust. I'm talking about the best performing process, which can go from 48 to 240 hours of white rust, depends on the thickness and the kind of passivation and top coat you use. In that case, with the zinc alloy plating, we can go up to 500 hours, 300 to 500 hours of white rust and 1200 to 1500 hours of red rust. So we will be able to increase the life of the part in the field by 3 times by adopting alloys, replacing the zinc metal. So critical quality for any process, it is very important to maintain the process parameters. Similar way, when we talk about as the process become more and more complicated compared to the single zinc plating process, when you go for alloy plating, so you need to maintain the alloy composition more precisely. In a zinc plating, you need only maintain one metal, whereas in alloy composition, you need to maintain both the all the alloy metals in the recommended ranges. So quality control is very critical to achieve the desired quality. Pre-treatment discipline is important. And when we say a simple thing, electroplating, if you have to have a successful process quality or deposit quality, discipline is one of the most important thing. And the second thing is cleanliness. Cleanliness and discipline, if you maintain in electroplating plant, probably you have done almost 90% of the requirement. Rain flow, water quality requirements. So bath purification, frequent bath purification depends on the usage and incoming impurities. So analytical monitoring, now as a previous presentation shows that online and inline analytical methods which will make more robust control and controlled process sequence. So this can advance process improvement which are in the development and already implemented some of them. Today we have a boric acid free assessing process available which is running at several in India as well as overseas. And bright and fast alkaline zinc plating, when in the beginning it was normally the less bright process as in alkaline zinc, now we can achieve much glossier finishes. We have a longer bath life, adopting more discipline, the prevention of impurity generation and carbonate generation, the bath life can be extended. So reduce the bath renewal when by maintaining the generation of impurities level lower sides, we can increase the bath life. And smart manufacturing integration is which is in all the companies when we say the progress happened over last 20-25 years. So from manual plant to automatic plants, now most advanced system, and now the control, the analytical control is also automated. So real-time bath monitoring is possible today. And there are, I think one of the presentation was about that, the real-time bath monitoring analysis as well as dosing based on that. So automated dosing systems and predictive maintenance rather than preventive maintenance, predictive or production maintenance are always preferred and ensure that the desired quality. So quality of system integration, that's every OEMs now do audits and then quality systems are integrated, that itself will ensure that the process delivers its desired quality. Future trends, higher NSST without any sealer. The plating and passivation itself should be able to deliver higher corrosion resistance. Single stage black passivation without having the finishing stage. Cobalt free chemistry, which is already in place and running. Probably this will get popularized to other more applicators. So engineered COF requirement in the compared to the past requirement, it is more and more increasing. And now earlier they used to have only one or two COF requirement. Now they come up with a big range of 5 to 6 ranges of coefficient of friction numbers. And the digital platings are coming in the future trends. Yes. So cost of performance. So thickness always cost is always part of the sustainability. Cost improvement is it's a continuous process. So reduced thickness is a requirement as with the improved performance, with the reduced thickness. That's a future strategy. And extended service life cycle of the part, as especially when we talk about the automotive, the combustion engine vehicles used to have 10, 15 or 20 years of life, whereas when it goes to EV, that is endless life. So the parts also need to perform in the similar way. And lower total ownership costs. So overall, like with the lower thickness and the increased life cycle and improved efficiency, so total ownership cost must be reduced. The strategic outlook, sustainability driven innovations, which every research and development companies are doing and working on it. Thin and high performance coating, automation and smart manufacturing, functional engineered surfaces. The future is smart engineered zinc system, longer life with a lower environmental impact. Last slide. This Baki, thank you.
We come to the end of the session for the MFAI papers presentation. Thank you and congratulations to MFAI.
Thank you, everyone.
Thank you, Mr. Aditya and Mr. Sanal. Thanks for your nice presentation.
I know that. Yes.
MFI thanks for a longest chairperson, Mr. Vikas Paliwal. Thank you very much.
Speaker, only chairperson. Only the whole name.
Hello. Hello. Thank you, everyone. Today's session is over. From on behalf of MFI, we thank all the delegates who attended this seminar. Once again, thank you.
Thank you very much. Thank you very much.
चलेगा शुरू कीजिए काम
सर आप सब ऑफ पे है ना
Hello, everyone. Good evening. We will begin the closing ceremony of ISF 2026 shortly. I repeat, we begin the closing ceremony of ISF 2026 shortly. Requesting all our exhibitors and visitors at the premises of BIEC to kindly join us at the main conference hall. I repeat, all exhibitors and visitors at BIEC kindly join us at the main conference hall. I don't want the mic to cover my face. Um, associate partners. Gold sponsors. Association. हाँ जी. Was it decent? I'll just pretend to speak. Yeah, that's. Yeah, I know. I want ideas something I know. That trip.
5 बजे 5 बजे आज 6 बजे आज दिया ही नहीं ना सुबह से नहीं है आज दिया ही नहीं क्यों आपको मालूम नहीं मुझे मालूम क्या आपको अपने को भी नहीं मालूम तो बताएगा तो मालूम पड़ेगा ना राजन मुझे अरे तेरे मालूम नहीं है तो वो आता ये अनाउंसमेंट के लिए है वो नहीं तो 5 मिनट नहीं तो बोला माहिती तुला काय माहित नाही सगळं मला माहिती कसं असतं तिकडे अनाउन्समेंट करता माहिती आहे की नाही नाही गाडी आम्ही शिकली पता ना की emergency what was it? कौन होता है ऐसे कौन से हाँ नहीं तो आंसर करता है प्रेसिडेंट वो साथ तो लेके जाता है उसका आज आज क्या क्या आज आवाज है तो बैठ ना शरारत करता हूँ मैं पता बोलूँ कॉफी वाटर दे वाटर में जाएगा तो क्या काम नहीं ठीक है तो क्या करें
Check.
Yeah, man. Oh, that's nice. Let's go. Last.
Check. Attention to all exhibitors and visitors. If you are at the premises of BIEC for ISF 2026, I request all of you to join us at the main conference hall for the closing ceremony. I repeat, if you're at the premises of BIEC for ISF 2026, I request all of you to join us at the main conference hall for the closing ceremony. We will begin the closing ceremony shortly. The closing ceremony of ISF 2026 will begin shortly, requesting all of you to kindly take your seats at the main conference hall.
लगा दिया बैंक लगा और फिर फिर को लेके डिस्कस सारे टेक्स्ट मेरे को एक्स्ट्रा लाइक 10
नहीं बट अभी तो दे रहे
पानी भी भराई ना पानी की वो ये वाटर का देखिए तो कहीं रिचार्ज कहाँ करें या बाकी लोग आप क्या क्या पहले आए बाकी लोगों ने मुझे समझ लगी आप क्या क्या पहले आज करेक्ट लेकिन आज के दौर में क्या है ये तो बैंक के लायक से लगा पहले ये होना है कि कौन इसका क्लास है समझ के बाद से हमें कर दिया क्लास है हमें क्या है एंड एबी पे एक भी कंट्रोल कर लास्ट एमपी से मैनेजिंग ट्रस्ट नहीं चालू है एमपी ट्रस्ट आई विल वेरीफाई that is the thing but what is happening I will participate managing trustee then managing trustee may validate the trustee then the yes I can good on and on तब फिर आप खुद का ट्रेनिंग बना तब वो अदर भी Last week, I was working all my friends together. But when I close the mic, that means stop it. Close purpose. Close purpose. ये मतलब मुझे भविष्य में क्या फर्क पड़ेगा दोनों को मॉडल तो कम है हाँ वेरी गुड वेरी गुड Again, you will not confirm it. You will already get tips. We will not get it. I have been there. I don't like. Yeah. Enough for the bank. आप खोल देगा अगर ये माइक पे चालू किया हुआ आप खोल देगा आवाज क्या बोल रहा है क्लोजिंग सेरेमनी स्टार्टिंग 5 to 10 minutes मैंने इतना बोल क्लोजिंग सेरेमनी स्टार्ट in 5 minutes then after the conference चलेगा आप तो बोले ये अगर कुछ बात कहते हैं हम बात कहते हैं हाँ और आपको आ जाएगा और इधर चैप्टर जगह मेमोरी स्टेट पड़ी ये उनको क्या होता है That can be good. That's good. It can be good. Don't tell them about that. अभी काम करेंगे तुम काम कॉल करना और लास्ट में कॉल लेवल पे तो बन गए ये सात सारे काम का पड़ वहाँ पड़ के पढ़ना है ना काम काट आप बोलते बड़ी क्लास में हम बच्चे हैं लेकिन क्या भाई कुछ लोग ये सब हो गया आप जानते हैं माँ पढ़े नाम पढ़े हम आज पहले पढ़ेंगे तो ये है कि नाम आपको पढ़ा करनी वो भी अच्छी एक वो sort of program taking a job एक बार काम से काम ये लाइन तो 30 है कि कहाँ से मिल सकते और ये कितना है तो ये आप तो काम के नाम तक and rest of the now you need to go need to like I imagine for the every करते एक तो परे दूसरा क्या हाँ हुआ लेकिन आवाज पूरा आया नहीं बैटरी पूरा नहीं हो कौन दे रहा है मैं ये I'm showing you Mira, le que vender. Pero no está. Mira. Quiero ver cuánta pone. Cuánta pone plata. Eh, ote. ये बोले क्या? बोला कि देखो क्या है? देखो. वीडियो करने में जाते हैं. इंस्टा पर पटेगा. अगर ऑडियंस में किसी 25 में 25 बहुत देखा मैं मेरे पास 25 नंबर आएगा नहीं बेटा पेट्रोल देख के जरूरत पड़ेगी नहीं यार कोई राय नहीं तो लेकिन टाइम ही तो क्या
Yes. Feedback. Somebody wants to come and say something. So audience has that.
Yes, ये experience include for नाम नहीं दिखा था मैं तमिलनाडु लिख के but I don't think they are there. यहाँ पे ढूंढ के देना पड़ेगा 90% लोग फील होता भी तो मेरी बात वाकई गई थी क्या लेकिन मैं आपको देखा सिक्योरिटी गए नहीं रखिए खानी है तो आप जाओ
Claro.
The closing ceremony of ISF 2026 is to commence shortly, requesting everybody standing outside to kindly join us at the main premises. Good evening, everyone. And this is probably the last time I will say this. Welcome to ISF 2026. It's been a splendid 3-day power-packed exhibition. Are we all happy with how ISF 2026 went? Can I see a thumbs up from everyone, please? Fantastic. I am so glad to see that everybody in this room gave me a thumbs up. What a lovely way to start this. But there's an even better news. There is a good news that I bring to all of you today. The best surprise that we at ISF got today. And this is truly a historic moment, not just for MFAI, not just for ISF, but for our country. This morning, in today's election, Sri Madhav Singh from our very own MFAI was elected as the president of IUSF. A huge round of applause for Sri Madhav Singh for being elected as the president, everyone. This is truly a historic moment. Imagine all countries being headed by an Indian. This is truly India being developed very, very soon. Let me tell you something about IUSF. It is one of the global apex body representing surface finishing associations from across the world. We're not just talking India, we have gone global. It promotes international collaboration, international excellence, technical excellence, environmental responsibility, and it brings global industry standards. And today, that world body will be led by an Indian, Mr. Sri Madhav Singh. Again, everybody, a huge round of applause, and I would like to invite Madhav Singh, sir, to kindly come and join us on the stage. Followed by the president of MFAI, Manmohan Kapoor, to kindly join us to felicitate the president of IUSF. The claps can definitely be louder. An Indian representing at the global standard is truly a moment of honor for India. I now request the elected president of IUSF to kindly come and share few words.
Good evening, ladies and gentlemen. It gives me immense pleasure for my country, for MFI Metal Finisher Association that I am connected with, and myself again, of course. It has been a beautiful journey. 2016, I was given the task by the council, MFI council, where you go to Beijing in the World Congress and see what best you can do. It was then Mr. Sunil Goyal, he was the president, and we both had the vision. Yes, we already have gone the national level, but we need to go to the global level. The task was tough because say in China, to win the heart of the delegates and the many senior the members from worldwide. I just entered the cabin. I lost myself what to do, whom to meet, who is he, who is he. There we had one friend, Mr. Wellington from Australia. He introduced me to a couple of people. Friends, I interacted with him, Dr. Gabe. Dr. Gabe was number 2 in the ISF when it was founded. And during the interaction, I realized, talking to the various people, we realized, we hum kisi se kam nahi hai. We can do, India can do, and India can take the responsibility of ISF. There was a contest. Hong Kong was there. We were there, and there was a election. From nowhere, from zero, we reached to the 45%, and the remaining 55% was owned by the Hong Kong. And that fight was for the 2028 World Congress to be hosted in India. So 8 years back, I mean, 8 years duration we require for the staking the claim in the hosting the ISF World Congress. Yes, there have been a lot of the ups and downs in the ISF, the working, we did not have any godfather, but still we, with the support of the MFI council members, and we worked, and finally we reached to the where we wanted to be. Today morning there was the election of the World Council, and India has elected. India has won the presidentship. It is a prestige. It is the honor to country. I believe there is honor to country, and then MFAI, of course, who has been working towards that. And I really take this opportunity to thank you, the MFAI, thank you all the delegates, the exhibitors, supporters, who has made this status, I mean, reaching to the ISF this level possible with all your support and the cooperation. And thank you very much once again to you all. My colleagues in the council, I mean, have been very supportive. So it is a teamwork. It is a teamwork that has really worked to achieve something in the MFI. Thank you very much. Thank you.
Thank you very much, sir. Your contributions have already been immense for MFAI, and we cannot wait to see what you will bring at the IUSF platform. It is also truly a privilege to invite one of the founder members of the Metal Finishers Association of India, Shri Mahendra Bhai Kamdar. Sir has been truly inspirational, one of the pillars in founding this council. His contribution to this industry is unspeakable. I am so glad to have Shri Mahendra Bhai Kamdar with us. A huge round of applause. He was one of the founder members of MFAI, everyone. Yeah.
Very good evening. The President, Mr. Manmohan Singh Kapoor, and all other colleagues at Metal Finisher Association of India's Council, as well as the exhibitors, the members who are participating in this August association's activity, that is conference as well as exhibition. I am privileged and fortunate to be associated with this great international body called Metal Finisher Association of India. It started with 71. For 2 years, we used to talk to each other, convince each other, have a confidence and faith into each other, and then realize that yes, we too can sit together and think about the growth about the activity of associations such as with a technical conferences, technical knowledge, exhibitions, how to enhance the business activity, and so forth. Finally, during all these years, it is due to the members of the council who have dedicated themselves, devoted themselves. They have put their total energy, total hard work for enhancing the growth and many other things of the association's activity. This is visible by all of us. Without dedication, without trust, without individuals' relation, such association cannot bring or come to that level. This is all due to the all these years, during last 50 years, always at the council level members, they trust each other. First thing, trust each other. They believe each other and they support and help for enhancing their business activity, that is metal finishing and surface treatment. And then finally, they support each other at the association level also. Coming to this today's exhibition and technical conference, since last 6 months, they have forgotten their own personal business. They have forgotten their family members, totally devoting their full time, 24 hours time for this. Please believe me this. It's not a joke. Without this such a grand level, great level, unexpected level exhibition and technical conference is not possible at all. So it is the credit goes to all these council members and particularly Manmohan Singh, Madhav Singh, Eknath Amin, many more. If I start naming, few may miss my mind also. Kaushal Dabalia, Kaushik Dabalia, Sony, and many. Yadav, yes, Yadav and Jogani, new members. મને માફ કરજો કોઈ कुछ नाम रह गया तो फाइनली दैट हैपन. माधव सिंह तो है ही. Just now Madhav Singh has been elected as a president of IUSF. For the kind information, friends, 92, I was privileged to present as president of MFAI at IUSF conference at Atlanta City, 92 June 28, 29 and 30. And then they started knowing what is India. And I was given opportunity to talk about Indian potentiality about metal finishing and surface treatment. Finally, friends, many thanks to all of you. And particularly thanks to council member for inviting me at this level, at this age, to this podium, to this stage. Thank you very much. Aap sabka many thanks. I am just completing 91. Thank you.
I now invite the President and Managing Trustee of ISF to felicitate our guest.
This is our organization, family members. We are all family members. Thank you for felicitating, but your love and affection is more than enough.
Shri Mahendra Bhai Kamdar, I really hope that you're proud of seeing how far MFAI has come today. A huge round of applause, everyone. Thank you so much, sir. You know, events of this scale, this impact, and this excellence is never built on one individual. It is never the effort of one individual. It is the result of collective belief, shared vision, and strong partnerships. Our goal sponsors are not just supporters, they are pillars behind this movement. Their trust, commitment, and contributions have helped elevate this platform. And MFAI at ISF is truly honored to felicitate our gold sponsors at ISF 2026. Artec Surfin Chemicals Limited. A huge round of applause for Artec Surfin Chemicals Limited. Requesting one of the representatives of Artec Surfin Chemical Limited to kindly join us on stage, or an MFAI member to kindly collect their trophy on their behalf. Moving on, Chemtech Surface Finishing Private Limited. Consolidated Metal Finishing Private Limited. A huge round of applause. Thank you so much for joining us at the closing ceremony, sir. I request the President of ISF, Manmohan Kapoor, to felicitate joined by the Managing Trustee of ISF, Madhav Singh. One of our gold sponsors and pillars of ISF 2026, everyone. A huge round of applause. Followed by Electrochem Technologies India Private Limited, Grower and Whale India Limited, GTZ India Private Limited, MKS Atotech, McDermott and Thorne India Private Limited, finally Totini Metals and Chemicals Private Limited. I request the President and Managing Trustee of ISF to felicitate MKS Atotech for their contributions and presence at ISF 2026. It's because of individuals and companies like this that a platform like ISF was built for many to showcase their latest technologies in this industry. This is Totini Metals and Chemicals India Private Limited, one of our strong pillars for ISF 2026. It is again because of the shared vision, belief, and contributions of such companies because of which ISF is what it is today. A huge round of applause for Totini Metals and Chemicals India Private Limited. We now move to another very important segment, our association partners. They have played a vital role in strengthening this platform. Their collaborations reflect unity within the industry and a shared commitment towards growth, innovation, and progress. I'd like to mention their names today. Mentioning our association partners, Association of Metal Finishers Aurangabad, Coimbatore District Electroplaters Association, Electroplaters and Metal Finishers Association Vadodara, Jamnagar Electroplaters Association, the Machilipatnam Imitation Jewelry Park Members Welfare Association, Metal Finishers Association Nasik, Metal Finishers Association Pune, Rajkot Electroplaters and Metal Finishers Association, Ambattur District Electroplaters Association, Electroplaters and Metal Finishers Association Tamil Nadu, and we are so glad that you were able to be part of ISF 2026. We'd also like to recognize the North India Chapter President here with us. He's been with us on the first day, and sir, we are honored to have you here again with us. A huge round of applause for our North India President. I request you, sir, to kindly join us on stage. Mr. R.P. Katana, the North Indian President. Please, a huge round of applause for him. I would now request him to kindly share a few words.
थैंक यू। सबसे पहले तो मैं यहाँ ट्रस्टी माधव सिंह और हमारे ये नए प्रेसिडेंट जो बने हैं अब IUSF के बहुत बहुत मुबारकबाद देना चाहता हूँ, पहले भी दी है। और हमारी बॉम्बे टीम के प्रेसिडेंट मनमोहन कपूर जी बहुत बहुत, और जितना बॉम्बे टीम ने काम किया है बहुत बढ़िया, इसका हम हमेशा आभारी रहेंगे। नॉर्थ टीम को जो मान सम्मान दिया है और जो टीम ने यहाँ काम करा है, जो फैसिलिटी हमने देखी है, तारीफे काफिल है। पहली बार हम आपकी मेहमान नवाजी को देख के गदगद हो गए और ये बहुत अच्छा लगा है कि जो 2028 में आपने नॉर्थ में करा है, इसका हम इतना रखेंगे, हमें ऐसा लगेगा कि हम आपके मान सम्मान में कोई कसर नहीं छोड़ेंगे। दिल्ली के साथ साथ ना हम हरियाणा से भी बिलोंग करते हैं, तो हरियाणा में जब हमारा अच्छा कोई काम होता है तो हम बोलते हैं कि लठ गाड़ दिया। तो 2028 में हम लट्ठी गाड़ के रहेंगे। थैंक यू सो मच। और मैं आपको ये आश्वासन दिलाता हूं कि नॉर्थ में जो भी हमारा ये लगेगा, जितना ये है इसका 4 गुना होना चाहिए और उसको भरने की जिम्मेवारी और वहां के लोगों की जिम्मेवारी नॉर्थ टीम की पूरी होगी और पूरी तरह से उसको निभाएंगे। जो सरफेस ट्रीटमेंट का काम है, ये सब लोगों को पता है कि यहाँ भी देश विदेश के अन्य कोने से लोग आए हैं, नॉर्थ से भी बहुत लोग आए हैं, और ये सबे पता है कि सुबह हम जब उठते हैं, बाथरूम के नल से लेके और लास्ट को बंद करते हैं, स्विच तक, हवाई जहाज तक, कोई सरफेस ट्रीटमेंट के साथ कोई काम नहीं हो सकता। तो इसको एक बढ़ावा देना है। MFI का ये काम हमेशा रहा है कि दर बदर इसको नई टेक्नोलॉजी को दिखाते रहे हैं। बहुत बहुत धन्यवाद बॉम्बे टीम का, धन्यवाद, और नॉर्थ टीम की वजह से मैं तरफ से मैं बहुत बहुत धन्यवाद। थैंक यू। और एक और रह गया है, लोगों से, बाकी लोगों से भी आह्वान है, हमारे हरियाणा में 1-2 दिन टाइम पहले निकाल के आओ। एक कहावत है हमारे हरियाणा की, कुछ दिन तो गुजारो हमारे हरियाणा में, जहां चोर का मोर बना देते हैं पुलिस वाले थाने में। तो जरूर गुजारना है आप लोगों ने।
Thank you so much, sir. I would now like to invite the President and Managing Trustee of ISF to felicitate our guest. Mr. Ratan Pal Khatana, the President, North India Chapter. I would request our guests to continue to remain on stage as we recognize the other members of the North India Chapter. Mr. Sunil Kumar Khanna, Vice President. A huge round of applause for Mr. Sunil Kumar Khanna, Vice President. Requesting the President and Managing Trustee to kindly remain on the stage. Followed by Mr. Sanjeev Chauhan, Vice President. These are the people who've built the ISF platform. Can our claps be louder than this? This is Mr. Sanjeev Chauhan, Vice President. Mr. Sanjeev Chauhan, Vice President. Followed by Honorable Secretary Mr. Ketan Verma. A huge round of applause for Mr. Ketan Verma, the Honorable Secretary, North India Chapter, MFAI. Followed by Mr. Kaushal Kinra, Joint Secretary. This is Mr. Kaushal Kinra, Joint Secretary, the North Indian Chapter. Followed by Mr. Shashikant Chilla, Honorable Treasurer. Followed by Mr. Rajiv Kumar Agarwal, Joint Treasurer. There are few other members of the North India chapter who could not be present with us here today. I am going to read out their names to honor and mention their contribution. Before that, I would like to do a very small activity. Can we all raise our hands, please? Everybody, can I see you raising your hands? Yes. The other hand as well. Now try bring them together and give a good hand of clap because these people have been phenomenal in making ISF what it is. I am going to read out the names of the North Indian chapter folks who are not able to join us today. Mr. Ashok Kumar, Mr. Devinder, Mr. Ashu Bajaj, Mr. Ghanshyam Khurana, Mr. Pradeep Kumar, Mr. Varun, Mr. Vijay, and Mr. Gaurav. We are truly honored and very grateful for everything that you've done for MFAI and ISF. Like I always keep saying, this is not a single person's effort. This takes an army. This takes number of days and months and years of effort even. And today, I am honored to be calling the Executive Council members of ISF. I would now request the President of ISF to kindly join us on stage.
हाँ बोला लो Balla sahab would you like to speak?
I will request Mr. Ballaji to please come on the dais and talk about the exhibition for 2 minutes at least. Please, sir.
अच्छी बात हमारे लिए ही बना बड़े भाई बोल रहे Thank you very much for inviting me to the stage. What I would like to say that my association with the Metal Finishing Association of India goes back till early 1980. And since then, I, in my personal capacity and on behalf of my company, we have been very actively helping whatever capacity, whatever help we can do with them. See, I can say one thing that this organization has improved immensely and a lot. I remember the exhibitions which we used to see during the early 80s and now difference is great. And it is all coming because of the hard work, dedication, and effort put in by this executive council. I really congratulate them for making this effort absolutely extraordinary. We have been clapping for individual person now, but can we all stand up and give a standing ovation to the Executive Council for their stupendous work? Hats off to them. They are passionate about self. You know, when we go to exhibitions in China or any other country, it is organized by a company, which is for them, they are paid. Their people are also paid. But this executive council member, they have done above self. They have sacrificed their personal effort, life. They have sacrificed their even family time just to make sure that this event becomes successful. I, on behalf of myself and my company and my community, I wish them all the good luck that in future they do still better, they still do. But it will not be possible without our support, industry support, and that should always come to them unconditionally. Thank you very much.
I would like Mr. Jayesh Bhai, you can come on the dais for a moment, sir. We would like to congratulate you on the dais for becoming the honorary vice president of IUSF. Please come on the dais, sir. I would also like to bring to your knowledge that our ex-president, Mr. Sunil Goyal, is become the Secretary General of IUSF. So now we have a team of 3 joining IUSF from India. Out of 7 people from the council, we have got 3. So I think within next 3 years, जो बाकी 3 है वो भी हम cover up कर लेंगे and we will be there. So we'll be an international body now. Thank you so much, sir. बुला लीजिए तो फिर तो हमारा चालू रहेगा दूसरा
I would now like to call upon the President, Manmohan Kapoor, to felicitate the contributions of the Managing Trustee of ISF, Mr. Madhav Singh. A huge round of applause, everyone. From what I've noticed, we cannot stop thanking and honoring Madhav Singh sir for everything that he's done. I would now request Mr. Madhav Singh, the Managing Trustee of ISF, to felicitate and honor Mr. Eknath S. Amin, Trustee of ISF 2026. I would now like to invite Mr. Eknath S. Amin to kindly honor Mr. Kaushik Dhabalia, the Vice President of ISF 2026.
I would personally thank Mr. Kaushik Dabalia for booking such a huge area for MFAI ISF 2026. Thank you, Kaushik Bhai. Thank you very much.
To honor Mr. Nirmal Soni, the Honorable Treasurer, I now invite Mr. Madhav Singh to honor Mr. Nirmal Soni. You sir. We'd now like to honor Mr. Kaushal Shah, Joint Secretary. Mr. Eknath S. Amin, sir, we request you to honor Mr. Kaushal Shah. We'd now like to honor Mr. Praveen V. Mankar, the Joint Treasurer of ISF 2026 MFAI, requesting Eknath S. Amin, sir, to honor Mr. Praveen V. Mankar, Joint Treasurer.
Let's party.
We would now like to honor Mr. Anand Shah, member of ISF 2026, member of MFAI. I would now request Mr. Manmohan Kapoor, the president of ISF, to honor him. Followed by Mr. Hasmukh Jain, member of MFAI ISF 2026. I would now request Mr. Madhav Singh to present followed by Mr. Ashish Shah, member of MFAI. And now request Mr. Eknath S. Amin, sir, to present the memento to honor Mr. Ashish Shah. The next member we would like to honor is Mr. Sandeep Kundra, member of MFAI. We now invite Mr. Manmohan Kapoor, the president of ISF, to honor Mr. Sandeep Kundra. Followed by Mr. Amit Jogani, member of MFAI. I would request Mr. Madhav Singh, the managing trustee, to present the award. The next person we would like to honor is Mr. Harish Chandra Yadav, MFAI 2026. I would now invite Mr. Eknath S. Amin to present the award to Mr. Harish Chandra Yadav. Followed by Mr. Hemant Pathak, MFAI 2026. I would request the President, Manmohan Kapoor, to present the award to him. Followed by other members who are not present with us here today but put their soul into bringing ISF to life. Mr. Jagmohan Singh, Mr. Santosh Rane, Mr. Mahendra R. Kamdar. It is not just intellectual ideas or getting out of the box and deciding what to do. It takes an army, and that army means the hospitality team, logistics, and so much more. We would now like to honor our service partners. Do we have with us Pavilions and Interiors India Private Limited?
Well, yes.
Present here for all 3 days and did his absolute best to bring this to life. A huge round of applause. This is the representative for Pavilions and Interiors India Private Limited. We really want to mention how helpful he was, even with how dynamic an exhibition can like this can get. He was always on his toes, ready to help us. A huge thank you for you, sir. Followed by Shivom Enterprises. Do we have a representative of Shivom Enterprises with us here today? And how can we not we would now like to thank the place where you are sitting today. BIEC. What an incredible place this is. This has become a place to host incredible exhibitions. If we have a representative of BIEC, we would really like you to join us on stage. Irrespective, can we give a huge round of applause to BIEC, everyone? I would now like to invite all the council members on the dais. We would now like to invite Mr. Jayesh Shah.
Jayesh is a star of our conference exhibition. So we would like to get together and felicitate him. Jayesh bhai, please come.
Entire council of MFAI with all the council members on the stage, we would like to honor the president of MFAI. A huge, huge round of applause for Mr. Manmohan Kapoor, everyone. Requesting the managing trustee Madhav Singh to felicitate the president. This indeed was a successful Alexander 2026. Can I hear a huge cheer? You have successfully completed ISF 2026. Kuchindarka for all his efforts. And this has been incredible because of this team, everyone. It is now my honor to invite the President, Shri Manmohan Kapoor, to the stage to officially declare the closing of ISF 2026 and mark the opening of the next chapter. Sir, आप बोलो.
कौन आया? I'm sorry, we have forgotten some names. I think HEC is come here. HEC corporations. Who's that? HEC Hospitalities. Please come on the dais.
To close ISF 2026, I now call upon the President of ISF, Mr. Manmohan Kapoor.
Thank you, Shishma. You can mess my life, so stay away. I'll manage it. Distinguished guests, fellow members, MFAI, valued exhibitors, and friends. As we draw curtains to the Indian Surface Finishing 2026, I stand before you, heart full of gratitude and pride. These past 3 days at Bangalore International Exhibition Center has been a remarkable testament of the Reliance's innovation and collaborative spirit of the surface finishing industry. To our knowledge, the partners, my heartfelt thank you to Electrochem Society of India, Bangalore, for their invaluable technical support. The synergy between the industries and research is that truly drives our technology advancement. I would like to thank our sponsors and the gold sponsors, Artec, Chemtech, Consolidate, Metal Finishers, Electrochem Technologies, Grovel, GTZ, McDermott and Thorn, MKS Autotech India Limited, and Todani Metal and Chemicals India. And all the others 135 exhibitors who have showcased the cutting edge solutions to our exhibition. To the organizing committee, I must acknowledge the tireless efforts of MFAI Council along with the North India chapter. Their meticulous planning has made this complex event look very simple. मैं दिल से अपने तहे दिल से हमारे MFAI काउंसिल मेंबर्स को खास करके शुक्रिया अदा करता हूं। हर आदमी ने बढ़ चढ़ के हिस्सा लिया, हर आदमी ने मेहनत की, हर आदमी ने इसको सफल किया. So I will thank them from bottom of my heart. Thank you everyone. I would also like to thank my family members, not my family members, MFAI family members. हमारे परिवारों ने इतना सपोर्ट किया है हमें कि इट वाज इनक्रेडिबल. अगर उनका सपोर्ट नहीं होता तो शायद हम लोग यहाँ तक नहीं पहुंच सकते. हमारे घर में हम लोगों ने कई कई दिन तक हमारा काम रुका के हम लोगों ने MFAI के ऑफिस में बैठ के काम पूरे किए हैं. रात को 11-11 बजे तक हम लोगों ने मीटिंग्स की हैं. And then we have got this result, this fantastic result, what we have seen for last 3 days. So thank you, family. Thank you so much for your support. Our delegates, visitors, and thousands of industry professionals who came from India and across the world. The venue providers, BIAC, Pavilions and Interiors, Shivam Enterprise, and HSC Hospitality, thank you very much. As we leave the city of Bangalore, we carry forward the theme of precision plating and lasting perfections. Let us take the eco-friendly processes and sustainable innovations discussed here back to our factories and build a greener and more efficient India. Friends, I now officially declare the closure of ISF 2026. I wish you all a safe journey home and look forward to seeing you at the next milestone event 2028 in the north. Thank you everyone and welcome to the next event. Thank you so much.